Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question paper because a number of question papers with the detailed PDF solutions are available there. For a better preparation, you must download our app. The link is available in the description box. So here we go with the question number 1 for the AP EAPCET 19 May 2023 Shift 1 paper. We'll be solving the mathematical part of this paper in this particular video. Best of luck. Here we go. The range of the function, the question number 1 says the range of the function fx is equal to 4x minus 1 when x is greater than 3. And it's x squared minus 2 when x lies between minus 2 and 3. And it is 3x plus 4 for x less than 2. Okay, so I have 3 cases. First is when x is greater than 3, then you have fx is equal to 4x minus 1. That makes 4 into 3 minus 1, which is equal to 11. So that means fx will lie in the 11 to infinity range. Second case, when x lies between minus 2 and 3. So squaring on both the sides, you will have a okay, fine. First of all, for this case, fx is given by x squared minus 2. So as we are having that x is lying between minus 2 and 3, so what will x squared lie between? It will lie between 0 and 9. Right, so that means minus 2 is less than x squared minus 2 is less than 7, because if I'm subtracting 2 from here, so x squared minus 2 lies between minus 2 and 7. That means fx will lie between minus 2, because it's less than equal to 7. Next, third case. When x is less than minus 2, then you have fx is equal to 3x plus 4. So fx is equal to 3x plus 4. So when x is less than minus 2, this fx will be less than 3 into minus 2 plus 4, or this will be minus less, fx will be less than minus 2. So fx will lie between these two things in the range of these two. That means range of f will be equal to minus infinity to minus 2 union minus 2 to 7 union 11 to infinity. This is equal to minus infinity to 7 union 11 to infinity, or all the real numbers except 7 to 11 closed. Open 7 to 11 closed. This is option C. So here we have option C as the correct answer. Next is question number 2. The domain of the function y is equal to fx, where x and y are related to 2 raised to power x plus 2 raised to power y is equal to 2 is. So, okay, I have this thing. Or you can say 2 raised to power y is equal to 2 minus 2 raised to power x. Now y is defined if this thing is greater than 0, that means 2 is greater than 2 raised to power x, or creating the basis, you have x is less than 1. That means x will belong to minus infinity to 1. So this is the domain. Minus infinity to 1, and option B is the correct answer. Next is question number 3. The number of ordered pair xy for which this matrix is singular and symmetric matrix. See, for any matrix to be symmetric, for a matrix to be symmetric, you have Aij is equal to Abi for I greater than, sorry, for I greater than equal to 1 and j less than equal to 3. So now, for now you have x if I take x is equal to y is equal to 1. So you have this matrix 1, 2, 1, 2, 2, 1, and 1, 1, 2. So the determinant will be equal to 1 into 4 minus 1 minus 2, 4 minus 1 plus 1, 2 minus 2, which is equal to 3 minus 6. So minus 3, this is not equal to 0. So A is a non-singular matrix. A is a non-singular matrix. There is no XY pair. Therefore, there is no XY pair for which A is both singular and symmetric. Okay, so this makes option B to be the answer. Hope you understood. Question number 4, if A is given by this matrix and B is given by this matrix, then 2A plus 3B minus 5C is equal to 0. What is the value for C? Easy, right? So this is the A matrix. This is these are the elements. This is you have to find out like 2. You are given 2A plus 3B minus 5C is equal to 0. So let's write down 2A. A is 2, 1, 3 minus 1, 1 minus 2, 2 minus 3 plus 3 into 2, 1, 0, 3, 1 minus 1, 2, 3 is equal to, you can say this is equal to 5C. So let's multiply this by scalar. You have 4, 2, 6 minus 2, 2 minus 4, 4 minus 6 plus 6, 3, 0, 9, 3 minus 3, 6 and 9. This is equal to 5C. Let's add them. You have 10, 5, 6 and 7. Then you have 5 minus 7, 10 and 3. Right, this is equal to 5C. Let's take the 5 common now. You will have here 2, 1, 6 by 5, 7 by 5, 1 minus 7 by 5, 2 and 3 by 5. This is equal to 5C. So nothing but the C matrix is equal to 2, 1, 6 by 5, 7 by 5, 1 minus 7 by 5, 2 and 3 by 5. That makes option D to be the right answer. Here we have option D as the right answer. Hope you understood this. Let's move to the next question. Question number 5. The rank of this matrix is. First of all, what do you mean by the rank of the matrix? The maximum number of linearly independent rows or columns, like which is the biggest one of a matrix, is called its rank. Okay, so to find out the rank of the matrix, let's transform it to the easiest form. So I'll be doing some transformations. First is R3 will be transformed to R3 minus R1, R4 to R4 minus 2R1. So this will be equal to, this matrix will be equal to 1, 0, 2, 0, 1, minus 2, 0, minus 1, 2, and 0, 2, 4. Let's do some further ones. You have R3 to, I'll do the transformation like R3 is equal to R3 plus R2 and R4 to R4 minus 2R2. So now this matrix will be equal to 1, 0, 2, 0, 1, minus 2, 0, 0, 0, and 0, 0, 8. So if I transform interchange the third and the fourth row, now this matrix will be equal to, this will be 1, 0, 2, 0, 1, minus 2, 0, 0, 8, and 0, 0, 0. Therefore, the rank of this matrix, I have 3 non-zero rows. So rank of this matrix is equal to 3. That means we have option C as the right answer. Hope you understood this. Next is question number 6. Argument of this complex number 4 plus 2 iota upon 1 minus 2 iota plus this lies in which interval? So, okay. First of all, let's say this is the complex number 4 plus 2 iota divided by 1 minus 2 iota plus 3 plus 4 iota upon 2 plus 3 iota. I'll be doing like 4 plus 2 iota, multiplying the numerator and denominator with 1 plus 2 iota. Here was iota, okay. 1 minus 2 iota, multiply 1 plus 2 iota. Whole thing is this plus, same 3 plus 4 iota, 2 minus 3 iota, divided by 2 plus 3 iota, 2 minus 3 iota. So let's do the multiplication. You have 4 plus 4. No, this is 9 iota. 4 plus 9 iota plus 4 iota square. 4 plus, wait, this is, I'll write it properly. 4 plus 2 iota plus, this is 8 iota. 4 plus 8 iota plus 2 iota plus 4 iota square. Question number 6. The argument of this complex number, this plus this, lies in which interval? Let's say this is the complex number, z is equal to 4 plus 2 iota divided by 1 minus 2 iota plus 3 plus 4 iota divided by 2 plus 3 iota. So I can write the z as 4 plus 2 iota, multiply the numerator and denominator by 1 plus 2 iota plus 3 plus 4 iota 2 minus 3 iota divided by 2 plus 3 iota into 2 minus 3 iota. Let's open it up. You will have 4 plus 8 iota plus 2 iota minus 4 divided by 1 plus 4 plus 6 minus 9 iota plus 8 iota plus 12 upon 4 plus 9. So this will give me 10 iota upon 5, which is equal to 2 iota plus 18 minus iota upon 13. Okay, this was equal to your z. So this z can be written as, I'm taking the LCM. This will be 26 iota minus plus 18 minus iota upon 13, or you have 18 minus 25 iota upon 13. This is equal to 18 upon 13. 25 upon 13. So now these both are positive, so it lies in the first quadrant. Argument z is equal to tangent inverse 25 by 13 upon 18 by 13, which is equal to tangent inverse 25 by 18. And this is, of course, because this is greater than 1, so this is greater than, this angle is greater than pi by 4. As you have this thing greater than 1. So therefore, argument of the given complex numbers lies between pi by 4 to pi by 2, because we have two things. One is it lies in the first quadrant, and second thing, it is greater than pi by 4. So of course it is lying between pi by 4 to pi by 2. That makes option A to be the right answer. Hope you understood this. Let's move to the next question. Question number 7. The multiplicative inverse of z is. Okay. See, what is the multiplicative inverse of z? It is given by 1 upon z. So I can write it like 1 upon z into z conjugate divided by z conjugate. So this is equal to z conjugate upon this z multiplied by z conjugate, which is nothing but the modulus of z square. Because you know z into z conjugate is equal to modulus of z squared. So I have to match it with the options. It directly matches with option C. So this is my answer. Question number 7, the multiplicative inverse of z is, of course, it is given by 1 upon z, but I don't have 1 upon z in the options. Right, here is capital Z. And so I have to do something. I'll multiply the numerator and denominator by z conjugate. So this is equal to z conjugate upon z modulus square. Because you know that z into z modulus is equal to conjugate of, Z into Z conjugate is equal to modulus of Z square. So this is the answer to the question. I already have this in the option C. This is my answer. Next is question number 8. If 1 omega omega square are the cube roots of unity, then the root of this equation are. Okay. See, by inspection, I can clearly see that one of the roots is Z is equal to 2. This is one of the roots because I am having three roots for this equation, and Z is equal to 2 is one of the roots. So I have 8 into 2 cube, 12 into 2 square, 6 into 2 minus 28. This is equal to 0. So that's it. I clearly have Z is equal to 2 as one of the roots. Now, by the division of it, like Z minus 2 will be 1 factor. So I will divide this 8Z cube minus 12Z square plus 6Z minus 28. So I have Z minus 2 over here. This gives me 8Z square, 8Z cube minus 16Z square minus plus. I have 4Z square plus 6Z minus 28 plus 4Z. So this will give me 4Z square minus 8Z minus plus. I have 14Z minus 28 and here will be 14. So 14Z minus 28, this will cancel. All right. So now it will be, this whole equation can be written as 8Z square, 4Z plus 14 into Z minus 2 is equal to 0. So I've got my second equation, that is 8Z square plus 4Z plus 14 is equal to 0, or you have 4Z square plus 2Z plus 7 is equal to 0, or you can write it as Z square plus 1 by 2Z plus 7 by 4 is equal to 0. So Z square plus 2 into, I can write it like this, plus 1 by 16 is equal to minus 7 by 4 plus 1 by 16. This, let's make it a perfect square. Z plus 1 by 4 is a whole square is equal to minus 27 upon 4 into 4. So this Z is equal to minus 1 by 4 plus minus 27 root iota upon 4, or Z is equal to minus 1 plus minus 3 root 3 iota upon 4. Right. So you have this Z as minus 1 minus iota 3 root 3 upon 4, or minus 1 plus iota 3 root 3 upon 4. These are the two possible values for the Z. Right. Now I will write it as Z is equal to 2 plus minus 3 minus 3 iota root 3 whole divided by 4. And the same thing over here, 2 plus minus 3 plus iota 3 root 3 divided by 4. Right, why I'm doing so, you'll just come to know about it. Wait. So this is equal to 2 by 4 plus 3, I'm taking common, by 2 minus 1 minus iota root 3. And the second one will give you 2 by 4 plus 3 by 2 minus 1 plus iota root 3. Okay. I'm taking 2 over here. So now this is like 1 by 2 plus 3 by 2. This is equal to omega square. This value is omega square and this is omega. And here will be 1 by 2 plus 3 by 2 omega. Okay, I have these two values. So this is equal to 3 omega square plus 1 upon 2, and you have here 3 omega plus 1 upon 2. So therefore, the roots are, one was 2 and another one is 3 omega plus 1 upon 2, 3 omega plus square plus 1 upon 2. So these are the three roots. Let's check with the options. you have option B as the right answer. Hope you understood this. Next is question number 9. If Z1 is equal to 2 plus 3 iota, let's write Z1 is equal to 2 plus 3 iota. Z2 is equal to 4 minus 5 iota. And Z3, they are 3 points in the Arvin plane such that 5Z1 plus XZ2 plus 5Z3 is equal to 0, where X, Y belong to real numbers and Z3 is the midpoint on the line segment joining Z1 and Z2. Then what is the value of X plus Y? Okay. See, you are given that Z3 is the midpoint on the line segment joining Z1 and Z2. So Z3 is the midpoint. That means Z3 is equal to Z1 plus Z2 upon 2, or you have Z1 plus Z2 minus 2, Z3 is equal to 0. In the question, you are given this 5 Z1 plus X Z2 plus Y Z3 is equal to 0. To make the same equation, I'll multiply it with 5. So you have 5 Z1, this equation, 5 Z1 plus 5 Z2 minus 10 Z3 is equal to 0. Or you have here X is equal to 5. If I compare both of these equations, X is equal to 5 and Y is equal to minus 10. What you had to find out was X plus Y. So X plus Y is equal to minus 5. This is the answer to the question. Minus 5. We have option A as the answer. Hope you understood this. Next is question number 10. If the roots of this equation are in harmonic progression, then the root of this equation will be in. You are given that 6x cube minus 11x square plus 6x minus 1 is equal to 0. The roots of this equation are in harmonic progression. So if the roots are in harmonic progression, then you can write like 6 upon x cube minus 11 upon x square plus 6 upon x minus 1 is equal to 0. They are in AP. Question number 10. If the roots of this equation are in a harmonic progression, then the roots of this equation will be in. See, if the roots of the given equation 6x cube minus 11x square plus 6x minus 1 is equal to 0. If the roots are in harmonic progression, then the roots of 6 upon x cube minus 11 upon x square plus 6 upon x minus 1 is equal to 0. These roots are in arithmetic progression. So if the roots, let's take the LCM, you have 6 minus 11x plus 6x square minus x cube upon x cube will be equal to 0, or you have 6 minus 11x, 6x square minus x cube is equal to 0. That is, I'm writing it properly, minus x cube. Okay, and do this thing. X cube minus 6x square plus 11x minus 6 is equal to 0. Therefore, the roots of this equation, this is the same equation which is given to us in the question over here. Therefore, the roots of this equation are in AP. That makes option B to be the right answer. Hope you understood this. Next is question number 11. The number of elements in the set x belongs to integers x squared minus 7x plus 6 less than equal to 0 and x squared minus 3x is greater than 0 is. You are having two inequalities. First one is x squared minus 7x plus 6 is less than equal to 0 and x squared minus 3x is greater than 0. This can be written as x, like two factors will be x minus 1 and x minus 6 is less than equal to 0. So that means here the x is lying between 1 and 6. In this question, I'll take x common. X minus 3 is greater than 0. So if this is greater than 0, that means if x is less than 1, then, if x is less than 0 or x is greater than 3. Because in this case, both the x elements will be negative and negative will make it greater than 0. In this case, both the elements will be positive and a positive into positive will give you positive value. So from here, x, you are given in the question that x belongs to the integer. So that means I see these two things like x lies between 1 and 6 and here x is less than 0 or x is greater than 3. Only three possible values for x are 4, 5 and 6. So that means it contains three elements. Option C is the right answer. Hope you understood this. Next is question number 12. If 3 plus iota and 2 minus root 3 are the root of for this equation, then fx is equal to this, where a1, a2 till an belongs to integers, then the least value of n for which a of 0, the least value of n and the value of a naught is are respectively. Okay, see the coefficients of the equation are integers. Question number 12, if 3 plus iota and 2 minus root 3 are the root of the equation, fx is equal to a naught plus a1x, hold this, where a naught, a1 till a n, they are integers, then the least value of n and the value of a naught are respectively. So here you are given that these coefficients a naught, a1 till a n, they are integers. So coefficient of the equation are are integers. So if 3 plus iota is one root, then of course 3 plus iota will be the second root. And the second root, and you have a 2 minus root 3 as a one root. Then this will be your another root. So how many roots are there total? You have 4 roots, right? So fx is equal to 0 has minimum 4 roots, right? Which makes n's value as 4. Now the fx will be equal to, fx is equal to x, it will be equal to x minus 3 plus iota, x minus 3 minus iota, x plus, x minus 2. You have here x minus 2 minus root 3, x minus 2 plus root 3. Right. So now if I take a n is equal to 1, the value of a naught will be equal to, see from here the value of a naught will be equal to, I'll be putting the x is equal to 0. This will be equal to 3 plus iota 3 minus iota into 2 minus root 3 into 2 plus root 3. So this will be equal to 9 minus iota square into 4 minus root 3 square, right? So this is equal to 9 plus iota square. This is 9 plus 1. And here you have 4 minus 3. So this is equal to 10. So that means a naught is equal to 10 and n is equal to 4. That is the answer. So n was equal to 4 and a naught was equal to 10. That makes option B to be the right answer. Hope you understood this. Let's move to the next question. Question number 13. Alpha, beta, gamma are the roots for this equation. Then the cubic equation whose roots are 1 plus 4 alpha, 1 plus 4 beta, and 5 plus 4 gamma is. Here you have a fx is equal to x cube 3x square 4x plus 5 is equal to 0. And let's say 1 plus 4 alpha, which is one of the root. Let's say this is equal to x. That gives you alpha is equal to x minus 1 upon 4. Now, if alpha, beta, and gamma are the roots for this equation, then f of, wait, I'll write it again. Alpha, beta, gamma are roots of fx is equal to 0 equation. Then 1 plus 4 beta, 1 plus 4 gamma are roots of f of x minus 1 upon 4 is equal to 0 equation, right? So that makes the equation as x minus 1 upon 4 cube plus 3 into x minus 1 upon 4 square plus 4 into x minus 1 upon 4 plus 5 is equal to 0. This 4 and 4 will cancel, and let's take the LCM. So denominator, you'll have 64, x minus 1 cube, 12. Yep, this is 12 into x minus 1 square, 64, x minus 1, 320. Let's open. You have x cube minus 1 minus 3x into x minus 1 plus 12 into x square plus 1 minus 2x, 64x minus 64 plus 320 is equal to 0. On solving this whole, you will have x cube minus 3x square. This is my x cube minus 3x square plus 12x square. I'm concatenating like this and this terms. Then you have plus 3x minus 24x, right? And we are done with this. Plus 12, sorry, plus 64x. Plus 12 minus 64 minus plus 320 is equal to 0. On solving, you will have x cube minus plus 9x square. X cube plus 9x square plus 43x plus 267 is equal to 0. This is the equation, and we have option D as the right answer. Hope you understood this. Next is question number 14. When x is so small that its square and the higher powers can be neglected, then the value of this expression approximately is equal to. So do remember that x is very small, that its square and the higher powers, that means I'll be ignoring the square and the higher powers like 3, 4, and so on. Okay, so you have here 1 plus 3x upon 4. 1 plus 3x upon 4 power minus 4 root of 3 plus x divided by root of this 3 upon x, 3 minus x cube. So this is equal to 1 minus 4 into 3x upon 4 multiplied by root 3. I'm taking root 3 common from here, x power x by 3 power 1 by 2. And this is whole divided by 3 root 3, 1 minus x upon 3 power 3 by 2. So this is equal to 1 by 3, 1 minus 3x, 1 plus x upon 6, 1 minus x upon 3 power minus 3 by 2. Question number 14, when x is so small that its square and the higher powers can be neglected, then the value of this expression is. So here you are given one thing, that I can ignore the square and the higher powers. So let's write down the expression first. You have 1 plus 3 by 4 x power minus 4 multiplied by root of this whole thing divided by root of 3 minus x cube. Okay. So now I'll do one thing. First of all, this is like in the standard form. I'll keep it as such. 1 plus 3 by 4 into x power minus 4. I'm taking root 3 common from here. So this will be equal to 1 plus x upon 3 power 1 by 2. Okay. This is, I'm going to take 3 cube common from here. So this can be written as 3 into root 3, right? Because root 3 cube is equal to 3 power 3 by 2, which can be written as 3 root 3. This is, I'm again going to take a 1 root 3, 3 root 3 common. So this will be 1 minus x upon 3 power 3 by 2, and we'll be left with this. Okay. Now, this is equal to, these things will cancel, two things, they will cancel out, and you will have for this, I'm opening, you will have, see, this will be 1 plus x raised to power n. I'll be only going with 1 plus n into x, because x square and higher powers can be neglected. It is given in the question. Okay. So I will stop this expansion at these two terms only. Okay. So this can be written as 1, this is minus 4 into 3 by 4 into x, and this expansion can be 1 plus 1 by 2 into x by 3, and this I'm writing 1 by 3, and this is 1 minus x upon 3 power minus 3 by 2. Okay, so this is equal to 1 by 3, 1 minus 3x, 1 plus x upon 6 multiplied by this. Now I'm again gonna expand this one again. This is 1 minus of minus, this is minus 3 by 2 into x power x upon 3. So this is there. This can be 1 by 3, 1 minus 3x, 1 plus x upon 6, and 1 plus x upon 2. So this will be equal to 1 by 3. I'm going to multiply these two. 1 minus 3x plus x by 6. See, again, now we are given that x square and the higher powers can be neglected. So I will not count these two multiplication things. 1 plus x2. Okay. So 1 plus x upon 2 minus 3x. I'm ignoring the multiplication of these two because this x square will be involved, plus x upon 6. So you have 1 by 3. I'm going to take LCM over here. I'm ignoring, okay, 6, and 6 plus 3x minus 18x plus 1. This is equal to 1 by 18. Here you have x only. So this is equal to 6 minus 14x. Or you have 1 by 3 minus 7x upon 9. This is the answer to the question, 1 by 3 minus 7x upon 9. This is option A. So here you have option A as the correct answer. Hope you got that. Let's move to the next question, number 15. The coefficient of x square in the expansion of 1 minus 3x power minus 1 by 4 is. General formula for the expansion, 1 minus x raised to power minus p upon q is given as 1 plus p upon q multiplied by x plus p into p plus q upon 2 factorial into x square upon q square till infinity. Now, here in the question, I have this 1 minus 3x power minus 1 by 4. This is equal to 1 plus 1 by 4 into 3x plus 1 into 1 plus 4 upon 2 factorial into 9x square upon 16, so on till infinity. See here in the question, you have p as 1. This p is 1 and q is equal to 4. And you have this x, let's say this is some x, see, x is equal to 3x in the question. All right. Now you have to find out the coefficient of x square. So coefficient of x square is equal to this, ignoring the x square from here. So you have 1 into 1 plus 4 upon 2 factorial into 9 upon 16. That is equal to 5 upon 2 into 9 upon 16. Or you have 45 upon 32. This is the answer. Option D stands to be the right answer. Next is question number 16. The greatest term in the expansion of 1 plus x power 15 when x is equal to 1 by 2 is. Okay, see, TR plus 1 to be the greatest term. Let's say that. Okay, so I'm just assuming that TR plus 1 is any term which is greatest one. So that means TR plus 1 is always greater than equal to TR, right? And this gives you NCR into x raised to power. Here is 1 plus x. So this is into x raised to power r is greater than NCR minus 1 into x raised to power r minus 1. Let's open it up. So here you have n as 15 in the given question. So 15 CR into x power r is greater than equal to 15 C r minus 1 into x raised to power r upon x. This x raised to power r, they will cancel, and you have 15 factorial divided by r factorial into 15 minus r factorial. This is greater than 15 factorial upon r minus 1 factorial. 15 minus r plus 1 factorial. They will also cancel. So here was 1 by x. So now you will have 1 upon r into r minus 1 factorial into 15 minus r factorial is greater than equal to x was equal to 1 by 2. This is multiplied by 1 upon r minus 1 factorial. And this is 16 minus r. So this is 16 minus r into 15 minus r factorial. This will cancel, this will cancel. And ultimately you will have 1 by r is greater than equal to 2 upon 16 minus r. Or 16 minus r is greater than equal to 2r. That gives you 16 is greater than equal to 3r. Or you have 3r less than equal to 16 or r less than equal to, this is, okay, r less than equal to 5 1 by 3. So see, r is less than equal to 5 1 by 3. So nearest possible value, because r is an integer. So r is got to be 5 in this case, right? That means the general, the greatest term was taken as t r plus 1. So this is equal to t 5 plus 1. So this makes 15c5 into x raised to power 5. This is 15 factorial upon 10 factorial into 5 factorial. This was equal to 1 by 2 raised to power 5. So this you have as a 15 into, this is a 15 into 14 into, okay, I think in the options you have C5, right? So I will not open up this. I'll just keep it as 15C5 only, because the options contain 15C5, like these terms combinations only. This is into 1 by 32. So we have 1 by 32 into 15C5. This is the answer to the question, and you have option A to be the right answer. Hope you understood this. Next is question number 17. The number of natural numbers less than 500 in which no two digits are repeated is, okay, all one, how many we have? 9, one digit natural numbers. That is from 1 to 9, right? Now all two digit natural numbers, all two digit natural numbers, like you can have two places over here, and this place can have 9 digits and this place can have 9 digits as well, because see, this place can have like 1 to 9 digits, and one digit will be used up over here, and this one can have 1 to 0 digits, actually 1 to 10, 1 to or you can say not 1 to 0, sorry, this can have 0 to 9 digits, but excluding one digit used at tens place. Okay, so you have 81 digits, which are two digit numbers. Now, three digit numbers, let's see. Three digit numbers, but you are given the condition less than 500. So three digit numbers that are less than 500, they are like this place can be occupied by 1 to 4 only. So there are 4 ways to fill up this. 0 cannot be included. Numbers greater than equal to 5 cannot be included. So this can be filled up in 4 ways. And of course, one digit will be used, but you can fill it in 0 to 9, excluding one digit used at hundreds place. Used at hundreds place. So this can be filled up in 9 ways. And now this can be filled up in 8 ways, because 0 to 9 excluding two digits used at hundreds and tens place. Okay, so you have 4 into 9 into 8, that is a total of 288. Now you had to find out the total number of natural numbers less than 500, in which no two digits are repeated. They will be 9 plus 81 plus 288. Okay, so total numbers will be 288, 81, and 9. This is a total of 378. So this is it. You have option C as the right answer. Hope you understood this. Let's move to the next question. If n is f, sorry, if f n on question number 18, if n of n is equal to n infinite product from r is equal to 1 to 2023, don't mistake this with pi, n square minus r square, where n is greater than 2023. Then the value of ncn minus 1 when n is 2024 is, see, here you have n of n is equal to n into infinite product from r is equal to 1 to 2023, n square minus r square. This can be written as n into infinite product from r is equal to 1 to 2023, n minus r is equal to 1, 2023, n plus r. So you have n is equal to n 2024. Now this can be written as 2024 into some infinite product from r is equal to 1 to 2023, 2024 minus r by r is equal to 1, 2023, 2024 plus r. So this is equal to, I'm gonna take 2000, write 2024 over here. This multiplied by, I'm starting with r is equal to 1. So this is 2023 into 2022 into 2021, so on till 1. And this is multiplied with plus r. So you have here 2025, 2026, so on till 2000, this 2023, 2024, you have 4047 till 4047. So see, this is a series like 1, 2, 3 till 2023. Here you have 2024, and then you have till 4047. So this is equal to 4047 factorial. That was your value of n. Now you had to find out in the question n c n minus 1. n c n minus 1. This is equal to nc1. You know that nc n minus 1 is equal to nc1, and that is equal to n. So this is means this is equal to 4047 factorial, because you know one thing, that ncr is equal to nc n minus r. So you have 4047 factorial, option A as the right answer. Hope you understood this. Next is question number 19. If P is equal to tangent 15 plus cotangent 15, Q is equal to tangent 22 by and a half degree and plus cotangent 22 and a half degree, and R is equal to 54 degree plus sine of 18 degree, then their ascending order is. So here in the question you have P is equal to tangent 15 plus cotangent of 15. This is equal to 2 minus root 3 plus 2 plus root 3, which is equal to 4. And your Q was equal to tangent of 22 and a half degree, cotangent plus cotangent of 22 and a half degree. This is equal to root 2 minus 1, and this is equal to root 2 plus 1. So again, you have here 2 root 2, and R was given to you as sine 54 plus sine of 18 degree. I can't find anything that can match, but I know the sine 54 is equal to root 5 plus 1 upon 4, and this is equal to root 5 minus 1 upon 4. So this makes this, or you have root 5 upon 2. This is root 5 upon 2, or this is equal to root 5 upon 4, or you have 1.25 under the root, right? So now you had the P as equal to 4, Q was equal to 2 root 2, and R is equal to root of 1.25. So clearly you have R is the smallest one, and then you have Q, and then you have P. This is their ascending order, R, Q, P. This is option C. So here you have the right answer to the question. Next is question number 20. Cos pi upon 2 square upon multiplied by cos pi upon 2 cube multiply cos pi upon 2 power 4 till cos pi upon 2 power 10 is equal to what? Okay, see, one thing we know that cos theta into cos 2 theta into cos square 2 theta, so on, no, sorry, not cos square 2 theta, wait. 1 into cos theta into cos theta into cos 2 theta into cos power 2 theta into cos 2 power 3 theta, so on till cos 2 raised to power n minus 1 theta is equal to sine 2 raised to power n theta upon 2 raised to power n into sine theta. So here you have the first term as cos pi upon 2 power 4, 2 power 2 multiplied by cos pi 2 power pi upon 2 power 3, so on cos pi upon 2 power 10. This is equal to cos pi upon 2 power 10 into cos pi upon 2 power 9, so on cos pi upon 2 power 2. Yeah, right. So if I compare this with the standard one, cos theta into cos 2 theta into cos 2 power 2 theta, so on till cos 2 power, this is 8 theta. So here you have theta as pi upon 2 power 10, n minus 1 is equal to 8, or you have n is equal to 9. Right, so this, according to the formula, that was equal to sine 2 power n theta divided by 2 power n into sine theta. So this is equal to sine 2 power n pi upon 2 power 9 into pi upon 2 power 10 multiplied divided by 2 power 9 into sine pi upon this. So this is equal to, this will cancel with this 10. So numerator will have sine pi by 2. Denominator will have 2 raised to power 9, which is equal to 512. And the sine pi upon this can be written as cosecant pi upon 2 power 10. So this is equal to cosecant pi upon 2 power 10. So sine pi is equal to 1 multiplied by this. Okay. So this is the answer to the question, and you have option B as the correct answer. Hope you understood this. Next is question number 21. If sine alpha plus beta is equal to 5 sine alpha minus beta, then sine 2 beta upon 5 minus cos 2 beta is equal to. Okay. You have this thing, sine alpha plus beta is equal to 5 sine alpha minus beta, sine alpha minus beta, or you have sine alpha plus beta upon sine alpha minus beta is equal to 5 upon 1. Now applying componendo and dividendo. Componendo and dividendo. You have see, if you have A upon B is equal to C upon D, this can be written as A plus B upon A minus B is equal to C plus D upon C minus D. So this makes your given equation as sine alpha plus beta plus sine alpha minus beta upon this sine alpha minus beta is equal to 5 upon 1 upon 5. 5 plus 1 upon 5 minus 1. Sine A plus B plus sine A minus B, this is equal to 2 sine alpha cos beta. And sine A plus B minus sine A minus B, this is 2 cos alpha sine beta. That is equal to 3 by 2. Okay. All right. So then you have this as tangent alpha upon tangent beta is equal to 3 by 2, or you have tangent alpha is equal to 3 by 2 into tangent beta. Okay. So now you have to find out this sine 2 beta upon 5 cos 2 beta. To find was sine 2 beta upon 5 minus cos 2 beta. This is equal to 2 tangent beta upon 1 plus tangent square beta divided by 5 minus 1 minus tangent square beta upon 1 plus tangent square beta. Hope you're clear till here. Now further this is equal to 2 tangent beta upon 5 into 1, this was 1 plus tangent square beta minus 1 minus tangent square beta. And these two terms, this and this two terms will cancel out in the numerator and denominator. You have 2 tangent beta is equal to 5 plus 5 tangent square beta minus 1 plus tangent square beta. So that's equal to 2 tangent square. No, it was tangent beta only. 2 tangent beta upon 4 plus 6 tangent square beta. I'm gonna cancel 2 from the numerator and the denominator. You will have tangent beta upon 2 plus 3 tangent square beta. Or you can write it as like this only, half of tangent beta upon 1 plus 3 by 2 tangent square beta. This is equal to, this can be written as 3 by 2 tangent beta minus tangent beta upon 1 plus 3 by 2 tangent beta into tangent beta. So we have also one thing over here. In this case, we have tangent beta is equal to 3 by 2. Sorry, tangent alpha is equal to 3 by 2 tangent beta. So this can be written as tangent alpha minus tangent beta upon 1 plus tangent alpha into tangent beta. This is the formula for tangent alpha minus beta. So this is my answer, tangent alpha minus beta. We have option, sorry, D as the right answer. Hope you understood this. Let's move to the next question, number 22. Match the items of list A with those of list B. So here you have the first one. Let's pick up the first one. You have here, not the A, the very first one. You have sine square 5 plus sine square 10 plus sine square 15, so on till sine square 90. Okay, so you know one thing, if A plus B is equal to 90 degree, then sine square A plus sine square B is equal to 1. So if I get back to this equation, I will write it as sine square 5 plus sine square 85 plus sine square 10 plus sine square 80 plus so on it will go on. So in the end, you will have sine square 40 plus sine square 50. I'll be left with two values, that is sine square 45 plus sine square 90. So this is equal to 1, this is equal to 1. Let's check how many ones you have. So 1 plus 1 plus 1, how many times? You have this 8 times. 1 by 2 for this and 1 for this, 1. A sine of 90, right? So this is equal to total of 9 and a half, or that is equal to 19 by 2. So this matches with option B. Right. Now, the second one, tangent square 5 plus tangent square 5 plus tangent square 10 plus tangent square 15, so on till tangent square 85 I have. All right. So now if I have again one thing, if A plus B is equal to 90, then the wait here was plus or product. Sorry, this is product, not the cross. So this is all the way product. Okay. So then you have tangent A multiply tangent B is equal to 1. So let's pick up this tangent square 5 multiply tangent square 85 multiply tangent square 10 into tangent square 85 80 into multiply like so on. You have tangent square 40 tangent square 40. Okay, I'll leave it as such into tangent. No, sorry, this will be tangent square 40 into tangent square 50. Right. So these are the ones. I'll remove the squares now. This can be written tangent 5 into tangent 85 square, tangent 10 into tangent 80 square, so on, tangent 40 into tangent 50 square. So definitely this is 1 square into 1 square into 1 square. The answer has got to be 1 only. And this matches with the D option. Right. Let's pick up this one. Cos square 5 plus cos square 10 till cos square 180. So third part, cos square 5 plus cos square 10 till cos square 180. Uh, see, if you have A plus B is equal to 90 or the difference also equal to 90, then cos square A plus B is always equal to 1. So let's concatenate now. You have cos square 5 cos square 95 plus cos square 10 cos square 100 cos square 15 cos square 105 so on cos square 90 and cos square 180. Right. So this was equal to 1 plus 1. How many times? This is equal to 0 and this is equal to like minus 1 squared minus 1. How many times 1 will be added? It will be added 18 times. So you have a total of 18 for this and this is option C. Correct. Next is cot 5 plus cot 10, so on. So here you have fourth one, cot 5 plus cot 10 plus cot 15 it was till cot 175. Cot 175. So here, see, if you have A plus B is equal to 180 degree, then cotangent of A plus cotangent of B is equal to 0. That makes, I'm going to concatenate now. So cot 5, cot 175, cot 10, cot 170, so on, cot 85, cot 95, plus cot 90 I'll be left with. So this is equal to 0 plus 0 plus 0 17 times plus cot 90. So cot 90 is also equal to 0. That means it's 0. That's it. So you have A as the right answer. Okay, so this is like 1 is matching with B, 2 is matching with D, C, third is matching with C, and fourth is matching with A. This is option A. This is the right answer. Hope you understood this. Next is question number 23. If cos A plus cos B plus cos C is equal to 0 and this is also equal to sin A plus sin B plus sin C, then what is cos A minus B? Okay, so first thing, cos A plus cos B plus cos C is equal to 0. This gives you cos A plus cos B is equal to minus cos C. Let's say this is 1. And you also have sine A, sine B is equal plus sine C is equal to 0. Or you have sine A plus sine B is equal to minus sine C. Now squaring and adding 1 and 2. Squaring and adding 1 and 2, you have cos square A plus cos square B plus sine square A plus sine square B plus 2 cos A cos B plus sine A sine B is equal to sine square C plus cos square C. So this is equal to 1 plus 1, 2 plus this is cos A minus B, and this is equal to 1. Or you have cos A minus B is equal to minus 1 upon 2. Okay, I think this is we needed to find out. Option D is the correct answer. Hope you understood this. Next is question number 24. If sine x into cos h y is equal to cos theta and cos x into sine h y is equal to sine theta, then sine square x plus cos h square y is equal to, you have sine x into cos h y is equal to cos theta, and cos x into sine hy is equal to sine theta. So squaring and adding both of them. Squaring and adding both. You will have sine square x cos h square y plus cos square x into sine h square y is equal to sine square theta plus cos square theta. Right? So this is equal to sine square this, cos this, plus this. This is equal to 1. I'm going to take now sine square x common. Not common. I'll open up this. This is equal to 1 plus sine h square y plus this thing. This is equal to 1. Open up. You have sine square x plus sine square x into sine h square y plus this sine h square y is equal to 1. Or you have sine square x. At this plus this is equal to 1. So this will be sine h square y is equal to 1. Now this can be written like sine square x plus like adding both sides 1. You will have this as 1 plus 1, or I'll simply write it as 2. Right? So, okay, this is equal to cos h square y. So this is equal to 2. And this is what we needed to find out. Sine square x plus cos h square y. This is equal to 2. And I have option B as the correct answer. Hope you understood this. Next is question number 25. In a triangle ABC, R is equal to 1, capital R is equal to 4, and delta is equal to 8. Then the value of this expression is equal to. Okay. You have one thing that in the triangle, let's write down, you have small r is equal to 1, capital R is equal to 4, and delta is equal to 8. You know, delta is equal to R into S, right? So that gives you 8 is equal to 1 into S, or you have S is equal to 8. What was S? It is semi-parameter A plus B plus C upon 2. Now you had to find out A plus B, 1 upon B plus C, 1 upon C plus A. So I will take the LCM, A, B, C. You have C plus A plus B. So this is equal, this gives you 2S is equal to A plus B plus C. Correct? So you have 2S upon, what is ABC? That is equal to, wait, one more formula you have, that ABC upon 4R is equal to delta. Or you can say ABC is equal to 4R into delta. So this is equal to 4R into delta. S was equal to 8. So 2 into 8, capital R was equal to 4 and delta was equal to 8. All right. So now this is question number 25. In a triangle ABC, if R is equal to 1, capital R is equal to 4, and delta is equal to 8. So we have R is equal to 1, capital R has 4, and delta is equal to 8. Then you have to find out this expression. Before starting with the question, I would like to discuss some formulas that delta is equal to R into S. Also, delta is equal to ABC upon 4R. Okay, or you have ABC is equal to 4R into delta. Now I have to find out 1 upon, before that, I would like to also define one more formula. We have delta is equal to R upon S. Delta was equal to 8, R was equal to 1. So S is equal to 8. This is equal to A plus B plus C upon 2. This is equal to 8. Or you have A plus B plus C is equal to 16. Now let's get back to what we had to find out. It was to find was 1 upon AB plus 1 upon BC plus 1 upon CA, LCM, ABC. You have C plus A plus B, or A plus B plus C upon ABC. This is equal to 16 upon ABC was equal to 4 into 4R into delta. 4R into delta. You have 16. 4 capital R is this, and this is equal to 8. So you have 1 by 8 as the answer to the question. Okay, let's check. You have option C as the right answer. Hope you understood this. Next is question number 26. In a triangle ABC, if R is the in radius and R1, R2, R3, they are the x radii, then 1 by 4 B square sine 2C plus C squared sine 2B is equal to. Okay, see, 1 by 4 B square sine 2C, C square sine 2B. This is equal to 1 by 4 B square. Sine 2C will be written as 4 delta upon AB cos C. C square 4 delta upon AC into cos B. Because sine 2A is equal to 4 delta upon BC into cos A. All right. So now this expression will be equal to 1 by 4 delta, 4 delta into B upon A into cos C plus 4 delta upon A into C cos B. This is further equal to 1 by 4 delta upon A, B, wait. Okay, this is 1 by 4 into 4 delta upon A. I'm taking common B cos C plus C cos B. This is equal to delta upon A into, this is what? This is only A. So this is equal to delta itself. Now, this delta can be written as delta square upon delta, or because I don't have the delta in the options, right? I have to find out something else. Don't have the delta in the options over here. So this delta can be written as a delta square upon delta, or this is delta upon S into delta upon S minus A into S minus A into S upon delta, or this is equal to R. This is equal to R1, and this is cotangent of A by 2. So that makes option D to be the correct answer. Hope you understood this. Next is question number 27. In a triangle ABC, if A upon S minus A plus B upon S minus B plus C upon S minus C, this is equal to. Okay, see this one, I'm going to rewrite this whole expression in some way. So this can be S into S minus A upon S minus A plus S minus B upon S minus B plus S minus C upon S minus C. So this is equal to S upon S minus A minus 1, S upon S minus B minus 1, S upon S minus C I'll do one thing. I will not touch it. I'll just rewrite this one as such only. I will keep it like C upon S minus C only. Okay. I will not rewrite this one expression. So this is equal to, I'm going to take S common from here. This is 1 upon this plus 1 upon this plus C upon this minus 2. So now taking the LCM, this is S divided by S minus A into S minus C. This is S minus A plus S minus B plus C upon this minus 2 is equal to, this will be S into, yeah, this will be, see, S can be written as, you have this 2S. This is equal to 2S minus A plus B upon S minus A into S minus B plus C upon this minus 2. You have 2S is equal to A plus B plus C. So if I subtract like A plus B plus C minus A plus B, this will be equal to S into C upon this plus C upon this, right? So now again taking the LCM, this will be S minus A, S minus B, S minus C. So you have S minus C into C plus C. I'll do one thing. I'll take this C common because there is C both the sides, right? I'll take the C common. And here you have a S minus A into S minus B. This whole thing minus 2. So now this is, I'm taking C outside. This is S square minus S C plus S square minus A plus B into S plus AB whole divided by this thing minus 2. So further this is equal to C outside, you have 2S square minus SA plus B plus C plus AB, and this thing is equal to delta square upon S minus 2, or you have S into ABC upon, this will go upstairs, and this is else into ABC upon delta square minus 2. Because you have A plus B plus C is equal to 2S. So this expression here will be equal to C into 2S square minus 2S square plus AB upon delta square. S will be here. Okay, so these two will cancel and you will have F's into ABC upon delta square minus 2. This further is equal to, I will write it like this, S upon delta ABC upon delta minus 2. So this is S into ABC is 4R into delta upon delta into 1 delta. I will write as small r into S. So this is minus 2, 1 delta and 1 delta will cancel, and this S and S will cancel. So you will have 4R upon small r minus 2. This is the answer. 4 capital R upon small r minus 2. Here you have option D as the correct answer. Hope you understood this. Next is question number 28. If k upon kx plus 3 plus 3 upon 3x minus k is equal to this expression for all x belonging to R, except this minus 3 upon k, comma k upon 3, then both the roots of this equation are. So here in the question, you have this, right, is equal to k upon kx plus 3, 3 upon 3x minus k. Or cancelling the denominators and taking the LCMs, you will have a 12x plus 5 is equal to k into 3x minus k, 3 into kx plus 3. Now equating corresponding coefficient in the given equation, we will get 3k. First of all, let's write it once. 12x plus 5. This is equal to 3k plus 3k into x. And then this is minus k square plus 9. Okay. So here you have 6k is equal to 12 or k is equal to 2, right? Therefore, the roots of kx square minus 7x plus 3 is equal to 0 are, this will be 2x squared minus 7x plus 3 is equal to 0, or 2x squared minus 6x minus x plus 3 is equal to 0, 2x, x minus 3 minus 1, x minus 3 is equal to 0, or you have the two factors as 2x minus 1 and x minus 3 is equal to 0. That makes x is equal to 1 by 2 or 3. So what are these two numbers? They are, of course, not the irrational, they are the rational numbers. Option A is the correct answer. Hope you understood this. Next is question number 29. Let A, B, C, D be the parallelogram where this, and this be the position vectors for A, B, and D respectively. Then the position vector of one of the point of trisection of the diagonal AC is. Okay. So you have the parallelogram A, B, C, D where you have this as A, B, and D. They're the position vectors of A, B, D respectively. Position vector of one of the point of trisection of the diagonal AC is. So see, you have OA as 2I plus J, or its direction ratios 2, 1, 0. OB as I plus 5j plus 4k. So this has like 1, 5, and 4. And OC as minus I minus 4j minus 3k. So this is equal to minus 1, minus 4, and minus 3. You have OC is equal to minus OA plus OB plus OD, because the midpoint of the diagonal are same. Therefore, you have a OC as minus 2, 1, 0 plus 4, 5, 4 minus 1, minus 4, minus 3, which is equal to minus 4. This is equal to 4 minus 1. Wait. This is equal to 4 minus 1 minus 2. And then you have 5 minus 4 minus 1, 4 minus 3 minus 0, which is equal to 1, 0, 1. So then the point which trisect ACR, point which trisect ACR, OA plus 2OC upon 3 and 2OA plus OC upon 3. So this is equal to 210 plus 101 upon 3, 2 into 210 plus 101 upon 3. So you have here 1 by 3, 4, 1, 2, 1 by 3, 5, 2, 1. This is 1 by 3, 4i plus j plus 2k, and 1 by 3, 5a plus 2j plus 2k. So this is option one of that, right? I have option B. This is one of the points. So option B stands to be the correct answer. Hope you understood this. Let's move to the next question. Question number 30. Let A, B, C be three non-coplanar vectors and the point of intersection of the line joining the points A plus B plus C and A minus B plus 3C. And the line joining the points this and this is. So first of all, the vector equation of the line passing through these 2 points. Vector equation of the line passing through these 2 points, A plus B plus C, and this is given by R is A plus B plus C plus lambda A minus B plus 3C minus A minus B minus C, where lambda belongs to any real number. So R is equal to A plus B plus C plus lambda minus 2B plus 2C. Let's say this is equation 1. And the vector equation of the line passing through these 2 points. Vector equation of the line passing through 2A minus B plus C and A minus 2B plus 4C is given by. Let's say this is L1 and this is L2. So here you have L2, the second equation, as R is equal to 2A minus B minus C plus mu A minus 2B plus 4C minus 2A plus B minus C. Yeah. So this is equal to, there was supposed to be plus C. So this R is equal to 2A minus B plus C plus mu minus A minus B plus 3C. All right. So at the point of intersection of, at the point of intersection of L1 and L2, you have A plus B plus C plus lambda into minus 2B plus 2C is equal to 2A minus B plus C plus mu minus A minus B plus 3C. Right. So equating, like here you have 1 minus 2 lambda into A plus 1 minus 2 lambda into B plus 1 plus 2 lambda into C is equal to 2 minus mu A plus, or here you will say minus this is A, and here is 1 plus mu into B plus 1 plus 3 mu into C. All right, so that makes equating the coefficients. You have 1 minus 2 lambda is equal to 2 minus mu, and you have 1 minus 2 lambda is equal to 1 plus, wait, sorry, I did a mistake over here. I'll rewrite this line because here was no coefficient of A. Okay, so this thing, this is equal to, here the A was missing, so this is not there. All right, so this is equal to 1 here. That makes 1 is equal to 2 minus mu, or mu is equal to 1. Here it was equal to 1 minus 2 lambda is equal to minus of 1 plus mu, or you have 1 minus 2 lambda is equal to minus 1 plus 1, that is equal to minus 2. From here, you will get the lambda's value as 3 by 2. So I got the value of mu as 1 and lambda is equal to 3 by 4. What you had to find out in the question was the point of intersection of this and the line joining. So I had to find out the point of intersection. For mu is equal to 1 and lambda 3 by 2. You have the equation 1 plus 2 lambda is equal to 5 mu minus 1. And I've put the values 1 plus 2 into 3 by 2 is equal to 5 into 1 minus 1. That is equal to 4 by 4 is equal to 4. That means the given lines are intersecting and their point of intersection. So therefore, lines are intersecting and point of intersection will be given by, it was, let's see, which was the equation. You can pick up any one of these, like these are the two equations. You can pick up any one. I'll pick up this one. So you had the point of intersection. This will be given by, it was 2A minus B minus plus C. It was 2A minus B plus C plus 1, this is the value of mu, minus A minus B plus 3C. This makes it A minus 2B plus 4C. So this is the answer to the question, A minus 2B and 4C. Let's check with the options. Option C is the right answer. Hope you understood this. Next is question number 31. The vector equation of any plane passing through the line of intersection of the plane r dot m1 is equal to q1 and r into m2 is equal to q2 is given by r into m1 plus lambda minus m2 is equal to q1 plus lambda q2. For all lambda belonging to the real numbers, the vector equation of a plane passing through this and this through this point and the point of intersection of this plane and this plane is. Okay. See, first of all, the vector equation passing through vector equation of a plane through intersection of given planes is given by pi 1 plus lambda pi 2 is equal to 0. So now here in the question, according to this, this is M1. Let's say this is M1 and this will be Q1 and this is M2 and this is equal to Q2. Now the vector equation of the plane passing through the point of intersection of these two planes is given by R dot, this is I minus 2j and this is 3I, this is I. So this will be equal to 1 plus 3 lambda I plus, here is minus 2, here is plus 1, minus 1 plus 1 into lambda j plus 3 minus 2 lambda k. Now, according to this equation, this is equal to q1 plus lambda q2. So this is equal to 5 plus 7 lambda. Now, it is given that this plane is passing through this point. Given that this plane passes through 2I minus 3j plus k point. So therefore, you have the r's value. This is 2I minus 3j plus k dot 1 plus 3 lambda I minus 2 plus lambda j 3 minus 2 lambda k is equal to 5 plus 7 lambda. Right? So let's do the multiplication. You have 2 into 1 plus 3 lambda minus 3 into minus 2 plus lambda plus 1 into 3 minus lambda. 3 minus 2 lambda is equal to 5 plus 7 lambda. Or you have 2 plus 6 lambda, 3 lambda, 6 minus this plus this is equal to this. On solving, you have lambda plus 11 is equal to 5 plus 7 lambda. Or you have 6 lambda is equal to 6 or lambda is equal to 1. So let's put this in equation 1, this one. Let's put in equation 1. Put this in equation 1. You have r dot 4I minus j plus k is equal to 12. So this is the required equation of the plane. All right. So now let's check. You have a C option as the right answer. Hope you understood this. Next is question number 32. Let A, B, C be three vectors such that A is perpendicular to B and B is perpendicular to C. If the modulus of A or the magnitude of A vector is 2 and the magnitude of B is 3, magnitude of C is 5, and ABC plus the sum of ABC magnitude is equal to 4 root 3, then angle between A and C is. Here you are given that A is perpendicular to B. That means their dot product is equal to 0. B is perpendicular to C. So you have this also equal to 0. And A's magnitude is 2, 3, and 5. Also one thing more, you have this magnitude as this. Okay, I'll pick up from here. You have A plus B plus C magnitude as 4 root 3. Squaring both sides, you have magnitude A square, B square, C square plus 2A dot B B dot C, C dot A. That is equal to 16 into 3, that is equal to 48. A's was 2, so this is 4, 9, 25. I have this as 0, this as 0. 2 into C dot A, this can be written like this. Theta is the angle between C and A. This is equal to 48. And you have the magnitudes. This is equal to 38 plus 2 into 5 into 2 into cos theta is equal to 48. Or you have 20 cos theta is equal to 10, or this is equal to 1 by 2. So that makes theta is pi by 3. So angle between A and C is pi by 3. Let's check with the options. We have here option B as the right answer. Hope you understood this. Next is 33rd question. Let A be this, B be this, C, D. They're the four vectors. If D is equal to this, this whole expression like vectors, okay? Then what is the value for X? So let's start with D. We are given that D vector is X into B cross C minus this plus this. Right. Now dot product, taking dot product of you on both the sides. Taking dot product on of A on both the sides. So you have a D dot A is equal to X dot A dot B cross C. Okay. Minus 7 by 9 dot, this is C cross A plus 7 dot A cross B. So these two, this is equal to 0 and even this is equal to 0. Dot product with the cross product of A and C and A and B, they are 0. So that makes D dot A is equal to X dot A dot this. This makes X is equal to D dot A upon A dot B cross C. Or you have this as D dot A dot product of this. Wait, this is A, B, C. So X is equal to, D was equal to minus 4, 5 and minus 3 dot with the 1, 1 and 1 whole thing divided by, I have to take the product, right? So this can be 1, 1, 1. A is 1, 1, 1. And B is 1, 1, minus 2. C is 1, minus 2 and 3. So let's solve this. You have this as minus 4 plus 5 minus 3 divided by its magnitude. This will be 1 into 3 minus 4 minus 1 into 3 plus 2 plus 1 into minus 2 minus 1. So this is equal to minus 2 upon, this is minus 1, minus 5 and minus 2. So you have this as a, sorry, minus 3. Okay, so you have this as 2 upon 9. That's it. I got the value that I was looking for. And this is equal to 2 by 9. Option B is the right answer. Hope you got that. Next is 34th question. The mean deviation from the mean of this data is. So actually this is very easy. Mean deviation from the mean of the data. First of all, let's find out the mean. This is 6 plus 7 plus 10, 12, 13, 4, 12 and 16 divided by the number of terms, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. That is equal to 10. We calculated the mean. Now you have to calculate the mean deviation. That is a mean deviation from the mean. This is given by summation from I is equal to 1 to n x, summation xi minus x bar, which is the mean divided by n. So in this case, let's solve it here itself. You have the first term, the mean came out to be 10 and the first term was equal to 6. So this is modulus of that, modulus of 10 minus 4. So this is equal to 4, 3, 0, 2, 3, 6, 2, and 6 divided by the number of terms, which is equal to 8. So you have 26 upon 8, or this is equal to 3.25. That makes option A to be the right answer. Hope you understood. Next, 35th question. It says the shopkeeper buys the particular type of electric bulbs from 3 manufacturers, M1, M2, and 3. He buys 25% of his recruitment requirement from M1, 45% from M2, 30% from M3. Based on the past experience, he found that 2% of type M3 bulbs are defective. Only 1% of M1 and M2 type are defective. If a bulb chosen by him at random is defective, then the probability that it was of the type M3 is. So, okay, let's first of all say we have 3 events. E1, E2, E3, they are the events that the bulb selected is from the manufacturer 1, 2, and 3 respectively. So the probability of getting even event to be happening is 25%, that is equal to this. This is 45%, and this is 30%. So this is 45 upon 100. This is 30 upon 100. Now, let A be the event that the bulb selected is defective. Let A be the event that bulb selected is defective. So you have probability A upon E1 is equal to 1%. It's given. And E2 defective, event E2 that the manufacturer's second one bulb is selected and it is defective. This is equal to, again, I think it's 1%. Yes. And probability A upon E3, this is 2%. Let me check. Yeah. Okay. So this is 2%. So that means this is 1 upon 100. This is this and this. So required probability that what was the required probability? The bulb chosen at random is defective and it is from the third manufacturer. So probability that event 3 happens and a bulb is defective. This is given by PE3 into P A upon E3 divided by summation R is equal to 1 to N PER. Right. A upon AER. This is according to Bayes theorem. So let's fill in. You have this as 30 upon 100. This is 2 upon 100, whole thing divided by. So first you have this as 25 by 100 multiply 1 by 100. 45 by 100 multiply 1 by 100. 30 by 100 multiply 2 by 100. So this will give you 60 by like 10,000, 10,000 numerator denominator will cancel. I'm not writing that. 25 plus this plus this. So this is equal to 6 upon 13. On solving, you will get 6 upon 13. And here it is. Option B is the right answer. Hope you understood this. Next is question number 36. Probability that a non-leap year contains 53 Sundays is. See, a non-leap year, non-leap year contains 365 days, right? So that means it has 52 weeks plus 1 another day, right? So now this, so of course, you are having 52 Sundays from here. And now this one day, it can be a Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. So probability that a non-leap year contains 53 Sundays, this is like 1 out of 7, right? See, you are having definitely 52 Sundays from here, and there is one probability, one Sunday out of the 7 options. So this probability is 1 by 7. So I'm having option A as the correct answer. Hope you understood. Next, 37th question. If A and B are two events of the random experiment, then the probability A union B is this, A intersection B is this. Probability P probability of A not happening and plus P probability B not happening is equal to. See, first thing you know that this is equal to this. So this can be written as 1 minus probability of event A to happen, B to happen. So you have 2 minus this plus this, right? And this is equal to probability A union B, A intersection B, right? Plus both of them. 2 minus this is 0.65 and this is 0.15. So this is 2 minus 0.80 or you have 1.2 as the answer. Option C. Hope you understood this. Next is 38th question. If a card is drawn at random from a well-shuffled pack of 52 playing cards, then the probability that it is either an ace or a spade card is. See, okay. Let A and B be the events. A and B be the events that the card drawn is ace and spade. Okay, so the probability of A event to happen, we are having 4 aces out of 52, and the spades, probability of B event, there are 13 spades out of 52. And probability of A intersection B, there is only one ace which is spade, so this is 1 upon 52. Now the required probability is equal to PA union B, this is equal to PB minus PA intersection B. So this is 4 upon 52 plus 13 upon 52 minus this. This is gonna give me this or 4 upon 13. So this is the answer, 4 upon 13, option A. Hope you understood. Next is question number 39. It says that the number of persons joining a cinema ticket counter in a minute follows a Poisson distribution with the parameter 6. Then the probability that at least one and at most 5 people join the queue in a particular minute is. So you are given Poisson distribution parameter as 6. So probability x is equal to r. This is given by e raised to power minus lambda into lambda raised to power r divided by r factorial. Now the required probability is 1 is less than equal to 1 lies between 1 and 5. So this is probability x is equal to 1 plus 2, 3, 4, and 5. So that is equal to this x is equal to 1. This is equal to e raised to power minus 6 plus multiply 6 power 1 upon 1 factorial plus this upon 2 factorial plus e raised to power minus 6, 6 raised to power 3 upon 3 factorial. Okay, e raised to power minus 6 into this upon this upon this. Okay, now I'll be taking some things common, which is 6 into e power minus 6. Inside I'll be left with, here is 1 and here will be 6 upon 2, that is 3. Here will be 6 into 6 into 6 upon 6, so this is 36. No, sorry, here will be 6 only. All right, because 6 I have already taken outside, and this will have 9 and this will have 10.8. So you have 6 into e raised to power minus 6. Adding all of that, you will get 29.8. So the answer to the question is this. Let's check. Option C. This is the right answer. Hope you understood this. Let's move to the next question. Number 40. If x is a random variable with the probability distribution, probability x is equal to k, then this is equal to k plus 1 into c upon 2 raised to power k, and k is 0, 1, 2, so on. Then probability that x is greater than 0, x is greater than 3 is fine. Know one thing, that sum of probability is equal to 1. Therefore, probability x is equal to 0, 1, 2, so on. This is equal to 1. Now, this is C plus, according to this is C upon 2 raised to 2 upon 2 raised to power 1 into C plus 3 upon 2 raised to power 2 into C, 4, 2 raised to power 3 into C, so on. This is equal to 1. I'm going to take C common. I have used this formula, okay, over here. So I have taken the C common over here. This will be 1 plus 2 into 1 by 2, 3 into this, so on. This is equal to 1. So, I know one thing, because 1 plus 2x, 3x squared, so on. This is the formula for 1 minus x raised to power minus 2, where x lies between -1 and 1. So now this is equal to c into 1 minus 1 by 2 raised to power minus 2. So this is equal to c into 1 by 2 power minus 2, or this is equal to 1, or you have this is equal to c, this is equal to c power 2, this is equal to, or you have c into 4 is equal to 1, or c is equal to 1 by 4. So that is it. I got the value of c as 1 by 4, and here I have option B, A as the right answer. Hope you understood this. Let's move to the next question. Question number 40, students, before starting with the question, is a quick reminder to visit our website www.examsnet.com. Here you will find this one and similar type of multiple entrance exam question papers. And for a better preparation, you must download our app. The link is available in the description box. Here we go with the question number 40. Let's read. It says, if x is a random variable with the probability distribution p, x is equal to k, given by k plus 1 into c upon 2 raised to power k, where k is 0, 1, 2, 3. And then you have to find out the probability that x is greater than equal to 3. All right. So students, you know one thing, that the sum of probability is equal to 1. That means probability x is equal to 0, 1, 2, so on. This is equal to 1. And according to this particular equation, this is given by c plus 2 upon 2 raised to power 1 c plus 3 upon 2 raised to power 2 c plus 3 upon 2 raised to power 3 c, so on. This is equal to 1. I'm gonna take a c common. This will be 1 plus 2 into 1 by 2, 3 into 1 by 2 square. And sorry, here was 4, not 3. It was supposed to be 4. 4 into 1 by 2 raised to power 3, so on. This is equal to 1. And you know one thing, that 1 plus 2x plus 3x plus 4x, 3x squared plus 4x cubed, so on. This is equal to 1 minus x power minus 2, where x lies between 1 and -1 and 1. Right. So, okay. That means this particular over here, you have x as 1 by 2. So this particular equation becomes equal to c into 1 minus 1 by 2 power minus 2. This is equal to c into 1 by 2 power minus 2. This was equal to 1. So you have c power 2 minus 1 power minus 2 is equal to 1. So you have c into 2 power 2 is equal to 1. That gives you c is equal to 1 by 4. Now, what you had to find out was this. So probability x greater than equal to 3. This is equal to probability 1 minus x is equal to 0 minus x is equal to 1 minus x is equal to 2. That is equal to 1 minus c minus c into 2 upon 2 raised to power 1 minus c into 3 upon 2 raised to power 2. So we just calculated c is equal to 1 by 4. So this is 1 minus 1 by 4 minus 2 upon, like this 2 will cancel. I'll just write it like 1 by 4. And this is equal to 1 by 4 into 3 by 4. So you have this as 1 minus 1 by 2 minus 3 by 8. Let's take the LCM. I'm having 8 over here. So this is 8 minus this minus this. So I have 1 by 8. Sorry, there's a mistake. He was supposed to be 4 4s are 16. So this thing will be now equal to 16 minus 8 minus 3. That gives me 11, right? So here you have a 5 upon 16. This is the answer to the question. We have option B as the correct answer. Next is question number 41. If the ends of the hypotenuse of a right angle triangle are this and this, then the locus of the third vertex is. So let's say this is the triangle. Here, this is a triangle, okay? And you have the 2 points for the vertex as, let's say this is A comma 0, and this point is B. 0 comma I, B is lying on the y-axis and A is lying on the x-axis for sure. And let's say this is the point P, x, y. So for which I have to find the locus, let P, x, y be a point on the locus, right? Since they are 90-degree, because we are talking about the hypotenuse of right angle triangle, that means slope of PA and multiply slope of PB is equal to 1. Slope of two perpendicular lines is equal to -1. The slope of PA is given by y minus 0 upon x minus a multiply y minus a upon x minus 0 is equal to -1. Or you have y square minus ay is equal to ax minus x square. Right. This gives me x squared plus y squared minus ax minus ay is equal to 0. So this is the required locus. That takes option A as the correct answer. Hope you understood this. Next is question number 42. The point 2, comma 1 is translated to the Purva point Q parallel to the line L is equal to L is x minus y minus 4 is equal to 0 by 2 root 3 units. If the point Q lies in the third quadrant, then the equation of the line passing through Q and perpendicular to L is. Okay. You are given the P point as 2, comma 1 and R, the distance is, it is translated to a point Q parallel to the line this by 3 units. So here R is equal to 2 root 3 and the given equation of the line is x minus y minus 4 is equal to 0, or you have y is equal to x minus 4. That means the slope here is equal to 1, which is given by tangent of theta. That makes theta as pi by 4. Right. Now to find Q, the general formula is given by, for the point, the general formula is given by x1 plus minus r cos theta, y1 plus minus r sin theta. Now to find out the point Q, you have already the P point as 2, comma 1 and I got the pi as theta as pi by 4. So the Q point, because it is lying in the third quadrant, therefore, the Q will be given by 2 minus 2 root 3 cos pi by 4, 1 minus 2 root 3 sine pi by 4. Right. So that is equal to, this will be 2 minus 2 root 3 cos pi by 4. This will be equal to by root 2, 1 minus 2 root 3, this So this is equal to 2 minus root 6, 1 minus root 6. I got the coordinates for point Q. Now it is given that you have to find out the point Q lies in third quadrant, equation of the line which is passing through Q and perpendicular to L. What was the slope of the line L? It was equal to -1. So line which is perpendicular to L, slope of line perpendicular to L is equal to -1, right? Because the slope of two perpendicular lines product is equal to -1. So slope of the line perpendicular to L will be -1. And we already have this point. Let's frame the equation using y minus y1 is equal to m into x minus x1. So you have y minus minus root 6 is equal to -1 x minus 2 root 6. So here you have y minus 1 plus root 6 is equal to minus x. I'll keep minus outside, minus 2 plus root 6, or this is equal to minus x plus 2 minus root 6, y minus 1 plus root 6 and root 6 will cancel. So you will have x plus y is equal to, sorry, this root 6 and root 6, they are having different sign. They will not cancel. Wait. Okay. So that's it. Yeah. So, okay, fine. You have x plus y. This is equal to 3 minus 2 root 6. So this is the value. This is the equation. X plus y is equal to 3 minus 2 root 6. We have option D is the right answer. Hope you understood that. Let's move to the next question. Question number 43. If O is the origin and P and Q are the points on the line 3x plus 4y plus 15 is equal to 0, such that OP is equal to OQ is equal to 9. You have to find out area OPQ. So here you have the triangle OPQ. This is O, this is P and Q. O is the origin. So, okay, O is the origin. P and Q are the points on the line 3x plus y. Here is the line 3x plus 4y plus 15 is equal to 0. OP is equal to OQ is equal to 9. You have to find out area OPQ. Let's drop a perpendicular from here to this line. Now, let's say this is M. So you have OM is perpendicular on PQ. So OM is equal to perpendicular distance from origin, which is 0, 0, to the line 3x plus 4y plus 15 is equal to 0. So OM will be given by the modulus of 0 plus 15 divided by root of 3 square plus 4 square. This is equal to 3. So OM comes out to be 3. Now you have to find out PM. PM squared, I'm applying the Pythagoras theorem. So you have PM squared. This will be given by OP squared minus OM squared. This is equal to 9 squared minus 3 squared. 9 squared minus 3 squared whole under the root. This is equal to PM. So PM is equal to 81 minus 9. That is equal to root of 72. Now, what you have to find out? Area of triangle OPQ. This is equal to twice area, or simply, fine. This is twice the area of area of triangle OPM. This is equal to half into base, which is PM, into height, which is 3. So these two things will cancel. In 72, this can be written as 6 root 2 multiply 3. So you have 18 root 2 square units as the answer. That is option D. So here you have the correct answer to the question. Hope you got that. Let's move to the next question now. Question number 44, the number of straight lines that can be drawn from the point minus 3, 4, which is a distance of 5 units from the point 2, minus 8 is. So you have the points. Let's say this is the point A, minus 3, 4. And let's say here is the point B, which is having the coordinates 2, minus 8. And let's say here is the point B. 2 comma minus 8. Right? This is a straight line. There's a distance between them. So distance between A and B, this will be given by root of minus 3 minus 2 square plus 4 plus 8 square, which is equal to 5 square plus 12 square. This is equal to 169, or this is equal to 13. Now, see, you want to find the number of straight lines that can be drawn through this point, which are a distance of 5 units from this point. So, 13 is greater than 5 for sure. Now, how many lines, such lines exist? See, if this is A and this is B, so the two lines which are passing through this, let's say these two lines, right? Such that if I drop a perpendicular from here to here, and from a perpendicular from here to here. Let's say this is point C and this is point D. Here you have AB is greater than BC. Also AB is greater than BD. Right? So how many such lines are there? There are two such lines. That is third option, option C. Right. Hope you got that. Next is question number 45. If the lines joining the origin to the point of intersection of this and this are at right angles, then which of the following is true? Fine, you having the equation 3x squared minus xy plus 3y squared. 2x 3y minus 4 is equal to 0. Let's homogenize the equation. This equation with the help of 2x plus 3y is equal to k. So you will have 2x plus 3y upon k is equal to 1. To get the point of, wait, this is the equation, something, it will look like this. This is something like, this is the curve. 3x squared minus xy plus 3y squared plus 2x minus 3y plus 4 is equal to 0. And this is the line 2x plus 3y is equal to 4, is equal to k. And here was minus 4, right? And this is the point, let's say A and B. Let's say this is point O. So this is something, wait, they will match, okay? This is the point O over here. And this, I have not drawn it properly, but this is 90 degree. Now, to get the equation for, to get the equation of OA and OB, you will have a 3x square minus xy plus 3y square plus 2x minus 3y, 2x plus 3y upon k, minus 4 into 2k plus 3y square upon k square. This is equal to 0. Let's say this is equation. Question number 45. If the lines joining the origin to the point of intersection of these two lines are at right angles, then which of the following is true? So you have these two, this is the curve 3x square minus xy, 3y square plus 2x minus 3y minus 4 is equal to 0. And this is the line 2x plus 3y is equal to k. Let this be the point of intersection A and this be the point of intersection, second point of intersection B. Now, if the lines joining origin to the point of intersection, so here is the origin. According to the question, they are intersecting each other at 90 degree angle. Now, homogenizing the equation 3x square minus xy, 3y square, 2x minus 3y minus 4 is equal to 0 with the help of 2x plus 3y is equal to k. Let's say this is first and this is second equation. You have 2x plus 3y upon k is equal to 1 to get the joint equation for OA, equation for OA and OB. You will have 3x square minus xy plus 3y square plus 2x minus 3y. I'm putting it like 1 and this is multiplied by 3x, 2x plus 3y upon k minus 4 into 2k plus 3y square upon k square is equal to 0. Let's say this is equation 3. Right, now you are given that OA and OB are perpendicular. They are intersecting at 90°. So therefore, the coefficient of x square plus coefficient of y square will be equal to 0. So let's use that from the equation 3, which we have over here. That means 3 plus 3 plus x square coefficient. If I pick up from here, this will be 4 minus 9 upon k. And from here, it will be the second one, 4 upon k square. 4 plus 9 is equal to 0. So here you will have a 6 plus 4 upon k. Sorry, this will write minus 5 upon k. This will be minus 13 fours are, because 52 upon k square is equal to 0. Or this will be equal to 66k square minus 5k minus 52 is equal to 0. So this is the equation to the line, to the pair of lines. And let's check with the options, which is the correct one. I have option D as the right answer. Hope you understood this. Next is question number 46. Let PQR be a right angle isosceles triangle, right angled at P to 1. If the equation of the side QR is 2x plus y is equal to 3, then equation of one of the sides other than QR is. So here is your figure. This is the given triangle. This is, let's say, P, the coordinates to 1, it's given. And this is Q and this is R. Yeah, given QR is having the equation 2x plus y is equal to 3. This is a right angle isosceles triangle. So if this is 90, this is 45 and 45. Right, that means these two sides, they are equal. Yeah, we are given these things and you have done the equation of the one of the sides other than QR is. Okay, so over here, if I use a formula, y minus y1 is equal to m plus minus tangent theta divided by 1 minus plus 1 minus plus m tangent theta into x minus x1. So here you have x1, y1 as 2, 1 and the slope of 2x plus y is equal to 3. The slope will be given by minus 2. And you have theta as 45. So this is equal to 1. Okay. All right. So now the equation will be y minus 1 is equal to minus 2 plus 1 upon 1 minus minus 2 into 1 into x minus 2. You have y minus 1 is equal to, this will be equal to 3. No, sorry, wait. Sorry, this is minus 1 upon 3 into x minus 2. And the second equation will be, or y minus 1 is equal to minus 2 minus 1 upon 1 plus 2 minus 1 into 1 into question number 46. Let PQR be a right-angled isosceles triangle at P2, 1. If the equation of QR is given by this, then equation of one of the sides other than QR is. So here is your triangle. This is the This is your triangle. It is right angled at P. The coordinates are 2, 1. And let's say this is Q and this is R. This is a right angled isosceles triangle. So this is 90. This is 45 and 45. These two sides are equal and you are given QR is given by 2x plus 3y. 2x plus y is equal to 3. Right? Okay, these things are given to us. Now, using the formula, you have y minus y1 is equal to m plus minus tangent theta divided by 1 minus plus m tangent theta into x minus x1. So, you have x1, y1 as 2, comma 1 and m is slope of 2x plus y is equal to 3. This is equal to this. So here the slope m is equal to minus 2. Also, theta is equal to 45. So you have tangent theta is equal to 1. Correct? Now let's get back to our equation. We had y minus 1 is equal to minus 2 plus 1 upon 1 minus minus 2 into 1 x minus 2, or y minus 1 is equal to minus 2 minus 1 1 plus minus 2 into 1x minus 2. Here you have y minus 1 is equal to minus 1 upon 3 into x minus 2, or y minus 1 is equal to 3 into x minus 2. Wait. Yeah, is equal to 3 into x minus 2. So from here you have 3y minus 3 is equal to minus x plus 2, or x minus 3y, x plus 3y is equal to 5. And from here you have y minus 1 is equal to 3x minus 6, or 3x minus y minus 5 is equal to 0. So these are the two equations. Let's check which of these is present in the given options. I have 3x minus y minus 5 is equal to 0. So this is it. I have option B as the correct answer. Hope you understood this. Next is question number 47. The coordinates of the points which divide the line joining this and this point in the ratio 2:4 externally is. So easy, right? So coordinates of the required point, the given points are 2, 3, 4 and 3 minus 4 and 7. So now these are the 2 points. This is being externally divided in the ratio 2:4. Let's say this is the x, y, z. Now it is being divided externally in the ratio 2:4. So this is 2:4. Here that is m and this is n. So the point of intersection, the point of division externally x, y, z, this will be given by x, y, z. This will be equal to. So here you have, this is 2 into 3 minus 4 into 2 divided by 2 minus 4, comma. Then you have 2 into minus 4 into 3 upon 2 minus 4. Then you have 2 into 7 minus 4 into 4 upon 2 minus 4. So this will be equal to 6 minus 8 upon minus 2. Here you have minus 20 upon minus 2. And then you have minus 2 upon minus 2. So you have 1, 10, 1. This is the answer to the question. And this is the point where they are getting, they are being divided externally. That makes option B to be the correct answer. Right? Hope you understood this. So let's move to the next question. And I hope you know the formula for this, the XYZ for the external division. It is given as m into x2 minus n into x1 upon m minus n into y2 minus n into y1 upon m minus n into z2 minus n into z1 upon m minus n. Next is question number 48. If a straight line is equally inclined at an angle theta with all the three coordinate axes, then what is the value for tangent of theta? So here you are having alpha plus beta, sorry, alpha is equal to beta is equal to gamma is equal to theta. And we know that cos square alpha, beta, and cos square gamma is equal to 1. So this makes cos square theta plus cos square, because all the three are equal. So this is 3 cos square theta is equal to 1, or you have cos theta is equal to 1 upon root 3. Or simply I will let it be cos theta, cos square theta is equal to 1 by root 3. Okay, fine. Then you have to find out the tangent of theta. Okay, so sine square theta is equal to 1 minus cos square theta. This is equal to 2 by 3. And tangent theta is equal to, or tangent square theta is equal to sine square theta upon cos square theta. So this is 2 by 3 upon this, or this is equal to 2. And you have tangent theta is equal to root 2. That makes option B to be the right answer. Hope you got that. Next is 49 question. If the planes 2x plus 3y plus 4z plus 7 is equal to 0, and 4x plus ky plus 8z is plus 1 is equal to 0 are parallel, then the equation of the plane passing through the point k and having the direction ratios of its normal as this is given by. Okay, question number 49. If the planes 2x plus 3y plus 4z plus 7 is equal to 0 and this are parallel, and then the equation of the plane passing through the point this having the direction ratios of its normal as this is. So you're given the two planes are parallel, and you know if the two planes are parallel, that means A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. So here you have 2, this upon 4 is equal to 3 upon K is equal to 4 upon 8. So this comes out to be like 1 by 2. This makes 3 by K is equal to 1 by 2, or you have K is equal to 6. That means I got the point. Point is 6, 6, 6. Now the equation of the plane through 6, 6, 6 and having direction ratios of its normal K minus 1, K plus 1. So this is 5, 6, 7. That means this is actually A, B, C. Now this is given by the equation general equation is of the form A x minus 1, B y minus y1, C z minus z1 is equal to 0. So here you have A as 5, x minus 6, 6, y minus 6, and 7, z minus 6 is equal to 0. This on solving will give you 5x plus 6y plus 7z is equal to 108. So now let's check which is the correct answer to the given question. This is it. You have option D as the correct answer. Hope you got that. Next is question number 50. It says let M be the point, this be the midpoint on the chord AB, and the circle is given by this. If AX plus BY plus 1 is equal to 0 is the equation of AB, then 3A plus 3B is equal to. Now, the given equation of the circle is x square plus y square plus 10x plus 8y minus 23 is equal to 0. Equation of the chord to this circle whose midpoint, so chord midpoint is given by this minus 7 by 2 and minus 5 by 2. Equation of chord of circle with M as midpoint is S1 is equal to S11. So this is x minus this, y into this, plus 5 into x minus 7 by 2 4 into y minus 5 by 2 minus 23 is equal to 49 by 4 plus 25 by 4 minus 35 minus 20 minus 23. This makes minus 7x upon 2 minus 5y upon 2 plus 5x minus this plus this is equal to this. Or multiplying both sides by 2, you have minus 7x minus 5y plus 10x minus 35 plus 8y minus 20 is equal to 37 minus 110. Or 3x plus 3y is equal to 37 minus 110 plus 55, which is equal to minus 18. So dividing both sides by 18, you have x by 6 plus y by 6 plus 1 is equal to 0. Now comparing it with the given one, ax plus by plus 1 is equal to 0 with the given equation. Comparing, you have a as 1 by 6 and b as 1 by 6. So what will be? Three a plus 3b, this will be equal to 3a plus b, or 1 by 6 plus 1 by 6. So 3 into this, or 1. This is the answer to the question 1. That is option B is the correct answer. Hope you understood this. Next is question number 51. If the inverse point of this point with respect to this circle is LM, then 2L plus 19M is. Fine. Polar of the point 3, 2 with respect to circle x squared plus y squared minus 2x 4y. This, let's say this is circle S. So polar of the point this with respect to this circle is given by x into 3, y into 2 minus x plus 3 plus 2, y plus 2 minus 4 is equal to 0. 3x 2y minus x minus 3 2y. This is equal to 0, or you have 2x plus 4y minus 3 is equal to 0. Let's say this is equation 1. Now, if the Q point, let's say HK, is inverse of P with respect to circle, then Q is the foot of perpendicular drawn from P to line 1. Then you have H minus 3 upon 2 is equal to K minus 2 upon 4 is equal to minus 6 plus 8 minus 3 upon this. This gives you minus 11 upon 20. So you have H minus 3 upon 2 is equal to minus 11 upon 20. And you have K minus 2 upon 4 is equal to minus 11 upon 20. Or you have H minus 3 is equal to minus 11 upon 10. Or you have K minus 2 is equal to minus 11 upon 5. And this will give you 10H minus 30 is equal to this. Or you have 10H is equal to, what will be 19, or H is equal to this. And K will be equal to minus 11 by 5 plus 2. So 5 LCM minus 11 plus this, so minus 1 by 5. I got the value of K as minus 1 by 5 and H as this. So this HLM was equal to HK. So this is this. You had to find out 2L plus 19M. So 2L minus 1 by 5 into 19. This will give me 19 by 5 minus 19 by 5, which is equal to 0. So that makes option C to be the correct answer. Right? Hope you understood this. Next is 52nd question. Let S be the circle concentric with this circle. If the length of the tangent drawn from the point this to the given circle is the radius of the circle S, then the power of the point 2, 1 with respect to the circle is. Okay. So equation of circle S concentric with circle 3x square, this is given by x squared plus y squared plus x upon 3, y upon 3 minus 1 by 3 is equal to 0, is of the form S is this plus k is equal to 0. Let's say this is equation 2. Now, length of tangent drawn from the point 2, minus 2 to the circle 1 is equal to radius of second circle, right? So this is given by root of 2 square minus 2 square plus 2 by 3 minus 2 by 3 minus 1 by 3. This is equal to 1 by 36 plus 1 by 36 minus k. So let's do squaring on both the sides. You have 4 plus 4 minus 1 by 3 is equal to 1 by 18 minus k. Or you have k is equal to 16, not sorry, 8 minus 1 by 3 minus 1 by 18. This is equal to, let's take 18 as the LCM. So here you will have 18 8 144 minus 6 minus 1, or you have minus 137. No, sorry, this is just 137. Wait. This is equal to minus k. This is equal to 137 upon 18, or k is equal to minus 137 upon 18. Right. What we had to find out in the question was the power of the point with respect to circle S is. Now, power of point 2, 1 with respect to the circle S is equal to 0 is given by S11. So this is equal to 4 plus 1, 2 by 3, 1 by 3 plus k is equal to 6 plus k. And what was k equal to? Wait, this is 5 and 5 plus 1, 6 plus k. Sorry, I just solved it over here. So this is equal to 6 minus 137 upon 18. That gives me 18 as the LCM, and 108 minus this. This will give me minus 29 upon 18. So this is the answer to the question, minus 29 upon 18. We have option C as the right answer. Hope you understood this. Next is question number 53. If P and Q are conjugate points with respect to this circle, then the radius of the circle is equal to. Fine, you have these 2 points, P and Q. They are conjugate with respect to this circle. Then you have S12 is equal to 0. So this makes S12 is equal to 0. So now this makes 2 into minus 1 plus 3 into 2 G 2 minus 1, 3 by 2 into 3 plus 2 minus 2 is equal to 0. Here 2G, so I have taken only G, and here F is equal to 3 by 2, so I have taken here 3 by 2. Hope you are clear with this. So this is equal to, totaling it, you will have a minus 2 plus 6 plus 2G minus 2 plus 9 upon 2 plus 3 minus 2 is equal to 0. Or you have this will be like minus 2, minus 2, minus 2, and the 6 they will cancel. And you have 2g plus 15 upon 2 is equal to 0. Or you have 4g is equal to minus 15. That gives you g is equal to minus 15 upon 2. Question number 53, if p, 2, 3 and q minus 1, 2 are the conjugate points with respect to this circle, then the radius of the circle is, fine. To know the radius of the circle, I need to find out actually the value of g only, because I already have f over here and c over here. So let's go to find out the value of g. You are given that p and q are conjugate points with respect to this circle, with respect to x square plus y square to gx plus 3y minus 2 is equal to 0. So in this case, you have S12 is equal to 0. So let's use these 2 points in this equation. You will have 2 minus 1 plus 3 into 2. And this is half the coefficient of here, g. So this will be g. I'm taking only 2 minus 1 plus here will be 3 by 2 into 3 plus 2. Yeah. And only minus 2 is left. So minus 2 is equal to 0. Here you have minus 2 plus 6 plus 2g minus g. Actually, this is g only. I'll just write g plus g plus 9 by 2 plus 3 minus 2 is equal to 0. Or you will have your, this will be 9 minus 4. 5 plus g plus 9 by 2 is equal to 0. Or you have g is equal to minus 5 minus 9 by 2, or you have minus 19 upon 2. This is the value for g. And let's find out the radius. You know, this is equal to g square f square minus c. So you have g we just calculated. This is equal to this. F is equal to 3 by 2. And square minus c. C was minus of minus 2. This will be plus 2. So here you have 19 square is 19 square was 361 upon 4, 9 upon 4 plus 2. So you have 361 plus 9 plus 8 upon 4, or this is equal to 378 upon 4, right? So let's do some cancellations now. Here you will have 1 and 8, 9, and here will be 2. So you have root of 189 upon root of 2, which will be equal to 3 root 21 upon root 2. So this is the radius. Let's check with the options. You have option B as the correct answer. Hope you understood this. Let's move to the next question. Question number 54, the line x plus y plus 2 is equal to 0 intersects this circle in 2 points A and B. Let the circle S, which is given by this equation, be a different circle passing through A and B if the distance of the center of S is equal to 0 from AB is root 2. Then what is G plus F plus C? Now, according to the given equation, you have S as this minus 4y minus 4. And this is a line which intersects this circle in the 2 points A and B. So S is given by a different circle passing through A and B. Fine. So S will be given by this plus lambda into x plus y plus 2 is equal to 0. Let's open it up. You have x squared plus y squared plus lambda plus 4 into x, lambda minus 4 into y, to lambda minus 4 is equal to 0. Let's say this is equation 1. Here the center is given by minus half the coefficient of x. So this is minus lambda plus 4 upon 2. And this is equal to 4, like minus lambda minus lambda minus 4 upon 2. So the center here is given by minus lambda minus 4 upon 2 and 4 minus lambda upon 2. This is the center. Now, perpendicular distance from the center, perpendicular distance from the center to line x plus y plus 2 is equal to 0 is given to you as root 2. So that means according to question, root 2 is minus lambda minus 4 upon 2 into 1 plus 4 minus lambda upon 2 into 1 plus 2 whole thing divided by root of 1 square plus 1 square. This will be equal to root 2 into root 2. This will give you minus lambda minus 4 plus 4 minus lambda plus 4 whole thing divided by 2. Right? So here you have 2 is equal to 4 minus 2 lambda upon 2. Or you have 2 is equal to 2 minus lambda. Or you have lambda is equal to 0. Right? So, okay, fine. There was a mod. Wait. There was a mod. So this may be equal to, you can have two values. So this was under the mod. This can be equal to plus minus 2. Right? That means 2 is equal to 2 minus lambda or minus 2 is equal to 2 minus lambda. Here you have lambda is equal to 0 and here you have lambda is equal to 4. And the two values for lambda, that is 0 and 4. Now, according to the given data over here, lambda is not equal to 0. That means we have lambda is equal to 4. Therefore, equation of the circle S will now become x square, y square, 4x, 4y minus 4 plus 4x plus y plus 2 is equal to 0, or you have x square plus y square plus 8x plus 4 is equal to 0. So that means here g is equal to 4, half the coefficient of x, and f is not existing over here, so f is equal to 0, and c here in this question is equal to 4. Now we had to find out g plus f plus c, that makes 4 plus 0 plus 4 or 8. So this 8 is the correct answer to the question, and option B is the right answer. Hope you understood this. Next is question number 55. If the focal chord drawn from the point P 5, 5 to the hyperbola y square is equal to 5x meets the parabola again at the point Q, then the tangent drawn to this parabola at Q meets the axis of the parabola at that point. You have this parabola. So that means 4a is equal to 5, which gives you a is equal to 5 by 4. So if a is equal to 5 by 4, let's see, this parabola looks something like this. This is your x and the y axis. So the parabola is something like this. This is the vertex. And this is 5 by 4, 0. And let's say to the point y, which is 5, 5. P 5, 5 is the point is. This is your x and the y axis. Now, P point, this will be given by 5 by 4 t square, 5 by 2 t. Now, according to question, you have this point as 5, 5, which is actually equal to 80 square, 280. So, which gives you that over here, you have a as 5 by 4. So, a t square is equal to 5 and 2at is equal to 5. A was equal to 5 by 4. Into t square, this is equal to 5. This gives you t square is equal to 4, or t is equal to plus minus 2. And from here also, you get the value of t as this is 2 into 5 by 4 to this. So 5 and 5, this, you have t is equal to 2. So here is t is equal to plus minus 2, here t is equal to 2. I'll pick t is equal to 2. So the point Q, which is this point, the point Q will be equal to now 5. This is given by a upon t square minus 2a upon t. This is the Q is the another end of this focal chord, right? So the coordinates of Q now will be, this will be 5 by 4 upon 2 square, which is 4, comma, minus 2 into 5 by 4 upon 2, which is equal to 5 upon 16 and minus 5 upon 4. Therefore, equation of tangent at the point Q, which is 5 by 16 and minus 5 by 4, this is given by y minus of minus this is equal to 5 by 2 x. Question number 55, if the focal chord drawn from the point P55 to this parabola meets the parabola at the point Q. Let's make the figure. So this is the coordinate axis and this is your parabola. It is touching this axis. So you have the parabola as y square is equal to 5x. That means 4a because I'm comparing with the general equation. So you have 4a is equal to 5 or a is equal to 5 by 4. So this is your focus, that is 5 by 4 comma 0. Let this be the point P 5 which is given in the question, and this is the focal chord, and this is the another point Q. This is your x and the y axis. Now the P point, which generally is given by like 80 square comma 280, and this is equal to 5 comma 5, and that means you have 80 square is equal to 5 and 280 is equal to 5. We have a as 5 by 4, so you have 5 by 4 into t square is equal to 5, or you have t square is equal to 4. That gives you t is equal to plus minus 2. Here you have t into 5 by 4 into t, 2 into 5 by 4 into t is equal to 5, or you have t as 2. So from these two equations, I definitely have t is equal to 2. Now, what will be the coordinates of Q? You will have the coordinates which will be given by a upon t square minus 2a upon t. I have all the values. So a is 5 by 4 and t square is 4 minus 2 into 2 into 5 by 4 divided by 2. So here you have the 2 points as Q will be given by 5 by 16 minus 5 by 4. This is the point Q. Now, what else you are given? Okay, Q is lying in the fourth quadrant. So you have X as positive and Y as negative. Right. Now, equation of tangent is given by the formula y into y1 is equal to 2a into x plus x1. So this will be y into minus 5 by 4 is equal to 2 into 5 by 4 into x plus 5 by 16. So you have minus 5 by 4 is equal to 5 by 2. Minus 5 by 4y is equal to 5 by 2 into x plus 5 upon 16. For finding out equation of the tangent, right? So here, if I put y is equal to 0, then you have x is equal to minus 5.6, 5 by 6. So the required point is minus 5 by 6, comma 0. This is the answer to the question. So here, why I have put this y is equal to 0 is because in the question they were asking the tangent meets the axis of the parabola at the point. So for the meeting the axis, you have to see this tangent will meet the if I draw a tangent from here, it will meet the x-axis somewhere. So at this point, y is equal to 0. So it will meet the x-axis at the point minus 5 by 6, comma 0. That makes option, it was 5 by, sorry, it is 5 by 6. No, it is 5 by 16. So it is minus 5 by 16, comma 0. We have option C as the correct answer. Next is question number 56. Tangents are drawn from the point 1, comma 1 to this ellipse if M1, M2, where M1 is greater than M2, are the slopes of these tangents, then with respect to the given ellipse, the point P, M1, M2 is. Fine. You're having the ellipse as x squared plus 4y squared minus 2x 8y plus 1 is equal to 0. This is your ellipse equation. Rewriting it, this can be written as x squared minus 2x plus 1 plus 4. I'm taking common y squared plus 2y plus 1 is equal to 4. And this is x minus 1 whole square, and this is y plus 1 whole square is equal to 4. Or you have x minus 1 square upon 4, y plus 1 square upon 1 is equal to 1. Now, equation of any tangent with slope m is given by y plus 1 m into m minus x, sorry, m into x minus 1 plus minus root of 4m square plus 1. So now through, this is passing through the point 1, 1, this one. So through point 1, comma 1. You have 2 is equal to 0 plus minus root of 4m square plus 1. Or you have 4 is equal to 4m square plus 1. Or you have 4m square is equal to 3. Or m is equal to plus minus root 3 by 2. So that means you have the 1 as m1 as this and m2 as this. Because in the question you are given that m1 is greater than m2. Now the point m1 comma m2, this becomes minus the root 3 upon 2 minus root 3 upon 2. Now S11 becomes, the given equation was x square plus 4y square minus 2x plus 8y plus 1 is equal to 0. So S11 becomes this, I'm putting, this will be 3 by 4 plus 4 into 3 by 4 minus root 3 minus 4 root 3 plus 1. So this is equal to 3 by 4 plus 4 minus 5 root 3. This is, see, this is, if I take, that's equal to 16 and 19 upon 4 minus 5 root 3. So definitely this is less than 0 because this is bigger value than 19 by 4. Therefore, the point, this point lies inside ellipse. S is equal to 0, right? Let's check. So it lies inside the ellipse. X is equal to 0. I have option A as the correct answer. Hope you understood this. Next is question number 57. Let E be the eccentricity of this ellipse. 1 by E be the eccentricity of a hyperbola, then the eccentricity of its conjugate hyperbola is. Okay, so you are having the ellipse as question number 57. Let E be the eccentricity of the ellipse given by this equation, and 1 by E is the eccentricity of a hyperbola, then the eccentricity of its conjugate hyperbola is. Here you have x square upon 4 plus y square upon 9 is equal to 1. Now in this case you have a square is less than b square, so eccentricity will be given by root of 1 minus a square upon b square, that is equal to 1 upon 4 upon 9. So 9 minus 4 upon this, or you have root 5 upon 3. This is the eccentricity of the ellipse, and you are given eccentricity of the hyperbola is 1 by e, so this makes it 3 upon root 5, right? And the eccentricity of the conjugate hyperbola will be given by eccentricity of conjugate hyperbola is given by EH dash, let it be. Now, according to the question, you have 1 upon this hyperbola eccentricity square plus its conjugate eccentricity square is equal to 1. And here you have this as 3 by 5. This will be equal to 5 by 9 plus 1 upon, here is E dash. E dash H square, that's equal to 1. That is, you have 1 upon E dash H square is equal to 1 minus 5 upon 9. This is equal to 4 upon 9. Or you have E dash H square is equal to 9 by 4, or you have EH dash is equal to 3 by 2. So this is the answer to the question. Eccentricity of the conjugate hyperbola is option D. Hope you understood this. Next is question number 58. Let x plus y plus 1 is equal to 0 and the x minus y plus 4 is equal to 0 be the asymptotes of the hyperbola h. If 1, 1 is a point on h, then the length of the latest fractum of h is. See, since the asymptotes of the hyperbola, this and this are perpendicular to each other. We are given that these are the asymptotes of the hyperbola. If 1, 1 is the point on it, then length of the latest fractum h is. Fine. So question number 58, let this and this be the asymptotes of the hyperbola h, and if 1, 1 is the point on h, then the length of the latest fractum of h is. You know, the latest fractum is given by 2a, so that means I have to basically find out in the question value of a. Let's start the two asymptotes which are given to us. The asymptotes are x plus y plus 1 is equal to 0 and x minus y plus 4 is equal to 0. Here you have y is equal to x plus 4. In this case, you have slope as 1 and this is y is equal to minus x minus 1. And in this case, you have slope is equal to minus 1. So these two asymptotes, they are perpendicular to each other. Therefore, the required parabola is a rectangular hyperbola. Required hyperbola is rectangular hyperbola with the eccentricity as root 2. And you are given that this point lies on the hyperbola. That means you have A is equal to B. Now the equation of the hyperbola will be given by equation of hyperbola will be x plus y plus 1, x minus y plus 4 is equal to, let's say, some k. Now it is passing through 1, 1. So this makes it 1 plus 1 plus 1 into 1 minus 1 plus 4 is equal to k. That makes k as 12. So now this equation becomes x plus y plus 1, x minus y plus 4 is equal to 12. Let's say this is equation 1. Now the equation of the x's will be given by equation of x's is given by x plus y plus 1 upon root 2 is equal to x minus y plus 4 upon root 2 plus minus. So cancelling these, you will have a x plus y plus 1 is equal to plus minus x minus y plus 4, or you have x plus y plus 1 is equal to x minus y plus 4, or you have x plus y plus 1 is equal to minus x plus y minus 4. Here you have 2y minus 3 is equal to 0, or you have y is equal to 3 by 2. And here you have 2x plus 5 is equal to 0, which makes x is equal to minus 5, 2. So here the center will be given by minus this and this. Let's say this is equation 2 and 3. Okay, now equation 2, that is, you have this y 3 by 2. This represents transverse axis, and equation 3, which is this is your conjugate axis, right? So now let's put y is equal to 3 by 2 in equation 1. You will get, what is that term? X plus y plus 1 into x minus y plus 4 is equal to 12. So you have this plus this into this plus this is equal to 12, or you have x plus 5 by 2 x plus 5 by 2 is equal to 12. This is x plus 5 by 2 square is equal to 12. Or you have x plus 5 by 2 is equal to 2 root 3. So I have x plus 5 by 2 as 2 root 3. This is nothing but 2a because x was equal to minus 5 by 2. So you got the value of a and you had to find out, this is a, sorry, not 2a. So you had to find out latest fractum, which is 2a. So 2 into 2 root 3, which is equal to 4 root 3. So this is the value for the latest fractum, 4 root 3. And here we have option A as the correct answer. Hope you understood this. Next is question number 59. Fx be this plus this and limit x approaching 1 minus fx is equal to, this fx is equal to L. And limit x approaching m, fx is equal to 5 by 2. Then the result of all possible finite values of L and m is, I'll start with the, you have limit x approaching m, fx is equal to 5 by 2. And according to this question, this is limit x approaching m, limit, this is equal to limit x approaching m root of x upon this plus this. So since it is approaching m, so this will be given by m upon 1 minus m plus root of 1 minus m upon m. This is given to you as 5 by 2 in the question. Let's take the LCM. You will have root m into 1 minus m. This is over here, this will be equal to m and this will be 1 minus m. This is equal to 5 by 2. Or squaring both sides, you will have m square plus 1 plus m square minus 2m whole multiplied by 4 is equal to 25 into m into 1 minus m. Let's open up the brackets. You have m square plus 2m square. 2m squared plus 1 minus 2m is equal to 25m minus 25m square. So you have here 23m square. Question number 50, let fx be this plus this function. And if you limit x approaching 1 minus fx is equal to L and limit x approaching m, fx is equal to 5 by 2, then set of all possible values of L and m is. Fine. So first thing I'll pick up limit. You are given x approaching m. F x is equal to 5 by 2. So this gives you limit x approaching m root of x upon this plus this is equal to 5 by 2. So let's put this as m. You have root of m upon 1 minus m plus 1 minus m upon m in the root. This is equal to 5 by 2. Let's take the LCM. So you will have root m into 1 minus m. Here will be m plus 1 minus m is equal to 5 by 2. These two things will cancel. You have a 2 is equal to 5 into root this. Squaring both sides, you have 4 is equal to 25m into 1 minus m, or you have 4 is equal to 25m minus 25m square. Here you have 25m square minus 25m plus 4 is equal to 0, or you have 25m squared minus 20m minus 5m plus 4 is equal to 0, or you have 5m common, 5m minus 4 minus 1, 5m minus 4. You have the two factors, 5m minus 1 and 5m minus 4. So the two possible values of m here are 1 by 5 and 4 by 5. So possible values of m are this and this. Now, for L, limit x approaching 1 minus fx is equal to L. This is finite. That means possible values of L are this as well. So this makes option finite possible values of L and M are this. Option D is the right answer. Hope you understood this. Let's move to the next question. Question number 6. A function of x is defined on a, b is discontinuous at x is equal to alpha, which belongs to a, b. Then which of the following is true? Since you are given that this function is defined on AB, right? And alpha belongs to AB. It's given in the question. And also you are given that the function is discontinuous at x is equal to alpha, which belongs to a comma b. Therefore, simply limit x approaching alpha fx is not equal to f of alpha. That makes option B to be the right answer. Hope you understood this. Next is question number 61. Let this represents the greatest integer function not exceeding t. Then the number of discontinuous points of 10 power x and greatest integer function belonging to 0, 10 is. So you have this fx is given by 10 power x greatest integer function, and here x belongs to 0 and 0, 10. I mean, it belongs between 0 to 10. So we are given here x belongs to 0, 10, from 0 to 10. That means if I take the power of x as 10, so this will be 1 and 10 raised to power 10, because anything raised to power here, this will be anything like the least value possible for raising the power to 10 is 1, right? 0 power 10 will be 0 and 1 power 10 will be 1. So I'll be taking like x power 10 lies between 0 and 10 to power 10. Therefore, now function is discontinuous at every point where 10 power x is an integer, as this is monotonic. That is, at 10 power x is equal to 2, 3, 4, 10 power 10 minus 1. Therefore, total number of points and discontinuity 10 to power 10 minus 2. So you have option C as the right answer. Hope you understood this. Next is 62nd question. At x is equal to pi square by 4. d by dx of tangent inverse cos root x plus secant inverse e power x is equal to. So I'll pick up this one. You have dy dx of tangent inverse cos root x plus secant inverse e power x. This can be written like tangent inverse. This is equal to 1 upon 1 plus cos square root x into cos x derivative. This will be minus sine x, and root x derivative will be given by 2 root x, 1 upon 2 root x, plus this is equal to 1 upon e raised to power x multiply e raised to power 2x minus 1 into ex, and they will cancel. At x is equal to pi squared by 4, this will be equal to 1 plus, this will be 1 plus cos pi by 2, which is equal to 0, minus sine pi by 2, that is equal to, okay, let's write down this first. It will be easy to do. So upon 2 into pi by 2 plus 1 upon root of e power 2 into pi square by 4 minus 1. So this will give me 1 upon 1 plus 0 into minus 1 upon pi plus 1 upon root of e raised to power pi square by 2 minus 1. Right. So this is equal to 1 upon root of e raised to power pi square upon 2 minus 1 upon pi. So let's check with the options. You have this option A as the right answer. Hope you understood this. Next is question number 63. Assertion: if fx is not continuous at x is equal to a, then it is not differentiable at x is equal to a. This is clearly true. See, obviously, if a function is not continuous at x is equal to a, then of course it is not differentiable at x is equal to a. If it is not continuous, it can never be differentiable. So this assertion is true. Next, fx is differentiable at a point, then it is continuous. Yes, of course, this is the reason for this assertion. So that means both are correct, and obviously we have option A as the answer. This is pretty easy one. Next is question number 64. fx is differentiable on R, and you have fx into f dash minus x minus f of minus x into f dash x is equal to 0. Also, you have f0 is equal to 3, f3 is equal to 9. You have to find out this expression. 1 plus f of minus 3 whole cube plus 1. Okay, now let's get back to our equation which we are given. So this can be written as fx into f dash x is equal to this. I'm taking it on the right hand side, f dash x. Okay, or you have f dash x upon f x is equal to f dash minus x upon f of minus x, taking integral on both the sides. Now, this integral, when I have taken, see, you have the function in the denominator and its derivative in the numerator in both the cases. So this is, of course, log of fx plus log of is equal to log of f minus x upon minus 1 plus c. So this is equal to log f x plus log f of minus x is equal to c. So you know this like log a plus log b is equal to log a into b. So this is equal to fx into f of minus x is equal to log c, or simply fx into f minus x is equal to c. Now if I put x is equal to 0, you know that f of 0, this will be f of 0 into f of 0 is equal to c, and this was equal to 3 and this was equal to 3. So that makes c as 9. Now our equation becomes f x into f minus x is equal to 9, and at x is equal to 3, you had f of 3 into f of minus 3. This is also equal to 9. That makes, f of 3 is equal to 3. You're given here. F of 3 is equal to 9. F of 3 is equal to 9 into f minus 3. So you have f minus 3 is equal to 1. Now let's get back to what we had to find out. We had to find was 1 plus f minus 3 square plus 1. I think this was it. Cube. Okay. Here was cube. Now this we had to find out. 1 plus this is equal to minus 1. 1 plus 1 cube plus this. So you have this as 9. So this is the answer to the question. Let's check. Option B is the right answer. Hope you got that. Let's move to the next question, number 65. The maximum value of a such that the second derivative of this function is positive or all real x. So let's write down the function. X power 4 a x cube 3x square upon 2 plus 1. So now here x belongs to the real number. Second derivative, first of all, let's find out. First derivative, this is 4x cube 3ax square 3x Second derivative, you have 12x square 6 ax plus 3. I'm going to take 3 outside, 4x squared, 2ax plus 1. Now, for the maximum value of a, the second derivative is positive for all real x. So, second derivative is always positive for all real x. That means 3 into 4x squared plus 2ax plus 1 greater than 0 for all real x, or you have 4x squared plus 2ax plus 1 is greater than 0. Here, discriminant is given by 2a squared minus 4 into 4 into 1. See, for this to be greater than 0, this should be less than 0. So that makes a 4a squared minus 16 is this, or you have a squared minus 4 is less than this, or a squared is less than 4. That makes a lie between minus 2 and 2. So the maximum value of a is of course 2. Maximum a value of a is equal to 2. That means you have option C as the correct answer. Hope you understood this. Next is 66th question. If f is a function from real to real numbers, be continuous. Px plus my plus n is a tangent drawn to the curve this at x is equal to alpha. Then at x is equal to 0, d by dx of this function is. Okay, see the slope of the tangent, slope of tangent at x is equal to alpha is given by f dash x, right? So for finding out this f dash x, let's say this was your function px plus my plus n is equal to 0. Here the slope, you have my is equal to minus px minus n, or y is equal to minus p upon m into x minus n upon m. So this is the slope. I'm going to fill it over here. Let's try to write it once again. You have f dash x is equal to minus p upon m. Now, d by dx of f of alpha into e power 2x is equal to f dash alpha e power 2x into 2 alpha e power 2x. At x is equal to 0, you have f dash alpha into 2 alpha is equal to minus p upon m into 2 alpha. This is equal to minus 2 into p into alpha upon m. So that makes D option to be the correct answer. Hope you understood this. Let's move to the next question. Question number 67. In the interval 1 by e comma e, it's a decreasing function among which of the following functions? So I have to check all the options one by one to check which is decreasing in this interval. First one, you have option A, fx is equal to log x upon x. Let's find out its derivative first. This will be given by x square into denominator into this x into 1 by x minus log x into 1. So you have 1 minus log x upon x square. Now in the interval 1 by e and e, this function will be, see, if I'm having e over here, here is 0. So towards this side is positive and towards this side it is negative. So that means f is increasing in 0 comma e. Therefore, this is not because we want a decreasing function. The second one, we have fx is equal to x square into log x. So f dash x in this case will be given by x square into 1 by x plus log x into 2x. Or I'll take x, this will be x plus 2x into log x, or this. Now, if I check it on the number line, this is for the interval 1 by e to e. This will be equal to 1 by root e. See, it will be decreasing in this and increasing in this particular interval. Yeah, so that means f is decreasing in this interval, right? So that's not our answer. Let's go with option C. You have fx is equal to x log x. So f dash x will be given by 1 plus log x on the number line. This will be 1 by e. It will be minus positive and you have a 0 over here. So f is decreasing in this interval. So that means this is even not our answer. Let's go with option D. You have f x is equal to x power minus x, or you have f dash x is equal to this on solving. So here is 1 by e. This is positive and negative on this side. So f is decreasing in this interval, right? So that implies, this implies this implies that the function is decreasing in this interval also, right? That makes your D option to be the correct answer. Hope you understood this. Next is question number 68. If the height of a cone of the greatest volume that can be inscribed in a sphere of radius r is kr, ratio of the volume of the cone to the volume of the sphere is. So here you have, this is the sphere and this is a cone inscribed in it. This is the cone. Now, the height of the cone of the greatest volume that can be inscribed in a sphere of radius r. So this, let me make the cone a bit right. So this is the cone. And this is the curved part. Here you have the center. Let's say this is the radius r. So this is the center O, this is r, and even this is r. Okay. Question number 68. If the height of a cone of greatest volume that can be inscribed in a sphere of radius capital R is KR, then the ratio of the volume of the cone to the volume of the sphere is. So this is the sphere and this is the biggest cone which can be inscribed in that particular sphere. Now, according to the question, this is the center of the sphere. Let this radius, not let, this is given in the question that the radius of the sphere is r, capital R. So this distance also is equal to r. This is also equal to r. And let's drop a perpendicular from here. Let this distance be x from here to here. And this radius of the cone is given by small r. Okay, so here r is radius of cone, and let this be the center of the sphere and this point be A, and we have taken OA to be equal to X. Let this point be B. Okay, so now in triangle AOB, capital R is equal to X square plus small r using the Pythagoras theorem. So volume of cone, what is the formula for that? Pi 1 by 3 pi r square h. So 1 by 3 pi. Over here, this is for the cone, right? So here r is equal to r square minus x square. And h is given by this r plus this x. All right. Let's open the brackets. You have 1 by 3 or pi by 3 r cube plus r square x rx square minus x cube. This was equal to your volume. Now for the maximum or the minimum value, let's find out the first derivative with respect to x. That is, v dash is pi by 3 taken outside. This is 0 plus 2, no 2. This is r square minus 2rx minus 3x square, or v dash is equal to, see, for the maximum value that can be inscribed inside the sphere, v dash should be equal to 0. This gives you pi by 3 r square minus 2rx minus 3x square should be equal to 0. Or you have 3x square plus 2 rx minus r square should be equal to 0. Let's split the middle term. 3rx minus rx minus r square is equal to 0, or you have 3x, x plus r, or you have r here, x plus r. So you have two things. You have two factors, 3x minus r and x plus r is equal to 0. Obviously, x plus r, this is not equal to 0, which simply means that 3x minus r is equal to 0, or you have x is equal to r by 3. Okay. Now, that means volume is maximum when you have x is equal to r by 3. Now let's get back to the question. What we had to find out was the ratio of volume of cone to volume of sphere. So required ratio, volume of cone divided by volume of sphere. Volume of cone, that is given by, it was pi by 3, and it was r square minus 2rx minus, no, sorry, this was the derivative. Volume was given by this, r cube pi by 3. This one was r cube. Let's write it. What was it? R cube plus r square x minus rx square minus x cube divided by volume of sphere, which is given by 4 by 3 pi r cube. So pi and pi, 3 and 3 cancel out, and x is equal to r by 3. Okay. So you have here r cube plus this into r by 3 minus r into r square by 9, r cube by 27, whole divided by 4r cube. Let's take the r cube common from the numerator. So you have r cube here plus 1 by 3 minus 1 by 9 minus 1 by 27 upon 4r cube. So r cube cancel, 1 by 4. Here you have, I'm going to take LCM, 27. So 27 plus 9 minus 3 minus 1. This is equal to 1 by 4 into 23. Sorry, no, 23 plus 9. That is 32 upon this, or you have 8 upon 27. So the required ratio is 8 is to 27. That makes option A to be the right answer. Hope you understood this. Next is question number 69. If fx is given by this for n greater than or equal to 2, and an integral of x raised to power n by minus 2 fx dx is equal to, okay, I'll start with what do you have to find out. Integral x raised to power n minus 2 fx dx. This is equal to x part n minus 2 into x upon, I'm filling in the value of fx, x upon 1 plus n x raised to power n raised to power 1 by n dx. So this is equal to 1 by n square integral 1 plus n x raised to power, this will be minus 1 by n into n square. I have multiplied and divided by n square into x power n minus 1, because I have utilized this one over here, dx, right? Further, this is equal to question number 69. If fx is given by this function for n greater than or equal to 2, then you have to find out this integral. Let's write down the integral. We have to find out x raised to power n minus 2 into fx dx. This can be written as integral x raised to power n minus 2 into x upon 1 plus n into x power n raised to power 1 by n into dx. Right, now I'll do one thing. I'll multiply the numerator and denominator by 1 by n square. I have taken 1 by n square outside. So this will be equal to 1 plus n into x raised to power n raised to power minus 1 by n into n square x power n minus 1 dx. Because I have utilized this x raised to power 1 and this one. Right, now you know formula because you have integral of fx power n into f dash x dx is equal to fx power n plus 1 divided by n plus 1 plus c. So now this particular equation will become 1 by n square multiplied by 1 plus nx raised to power n raised to power 1 minus 1 by n upon this plus c. So here you have this will be equal to n square multiply n minus 1 upon n. The numerator will remain as such. And this will cancel. You will have 1 plus nx raised to power n, 1 minus 1 by n power n divided by n into n minus 1 plus c. So that makes option A to be the right answer. Hope you understood this. Next is question number 70, again an integral problem. Students, before starting with the question, is a quick reminder to visit our website www.examsnet.com. Here you will find this one and many more entrance exam question papers. You must download our app for a better preparation of your exams. So now let's start with question number 60. You have to find out this integral. Let's write it down. You have 1 plus x cos x whole thing divided by x into 1 minus x square e power sin x square dx. This can be written integral e raised to power sin x. I'm multiplying numerator and denominator by this into 1 plus x cos x divided by 1 minus x e power sin x whole square dx. Now this is equal to, I'll write it as x into e power sin x plus, not plus, this is, okay, x into e raised to power sin x into e raised to power sin x plus this. I'm again doing one thing. I'm multiplying the numerator and denominator by this. So here will be square. I'm multiplied the numerator and denominator by x into e power sin x. Question number 70, again, we have an integral problem, students, but before starting the question, is a quick reminder to visit our website, www.examsnet.com. Here you will find this question paper along with its PDF solution and previous years many question papers with the PDF solutions as well. So students, you must download our app. The link is available in the description box for a better preparation of your exams. Let's start with this question number 70. You are given 1 plus x cos x whole thing divided by x into 1 minus x square e power sin x whole square dx. Let's do one thing. I'm going to multiply the numerator and denominator by e power sin x. So this is 1 plus x cos x divided by x into e power sin x 1 minus x. I'm taking this inside x, this whole square dx. Okay, so this again I'm doing one more thing. I'm going to multiply this with x into e power sin x in the numerator and denominator. So this can be written as like this, 1 plus x cos x divided by x into e power sine x whole square 1 minus x e power sine x square dx. I'll do one thing. I'll put x e power sine x square is equal to t, or you have 2x e power sine x e power sine x multiply e power sine x multiply 1 plus cos x dx is equal to dt. So now this integral I, let's say this is equal to I. Now this integral I will become integral of 1 by 2 t 1 minus t into dt. This is equal to 1 by 2. I'll do one thing, t plus 1 minus t upon this dt. So this is equal to 1 by 2, 1 upon t, 1 minus t plus this dt. Now let's find out the integral. This is equal to half minus log 1 minus t plus log t plus c. So this is 1 by 2 log t upon this plus c, or you have 1 by 2 log, there was minus sign, right? I have to utilize that. So I can write it like this, t upon t minus 1. Yeah. Oh, sorry, this one has been utilized already over here. So because the modular sign is there, I can write it like 1 minus t can be written as t minus 1 as well. Over here at this step, I have, this was in the minus and this was in the plus. So I have kept this t in the numerator and this thing in the denominator. Fine. And modulus of 1 minus t can be written as modulus of t minus 1. Both things are same. So now this thing, this expression is plus c. This expression now is equal to half log. I'm going to fill the value of t now. That is x into e power sine x square upon x into e power sine x square minus 1 plus c. So this is the answer to the question. And let's check with the options. You have option C as the right answer. Hope you understood this. Let's move to the next question, number 71. Again, an integral problem. You have dx upon x minus 1 root of x plus 2. I'll put x plus 2 under the root as t. So you have x plus 2 is equal to t square, or you have dx is equal to 2t into dt. So now this integral I will become 2t into dt, whole thing divided by t square minus 2 minus 1. Okay, I'm gonna, yeah, this can be written like this. Okay, so this is this integral. This is 2t and t will cancel. 2 upon t square minus 3 dt. This is, I'm gonna write again, 2 upon t square minus root 3 square dt. This is equal to 2 upon 2 root 3 log of question number 71, again an integral problem. So here you have dx upon this, right? I'll put this thing as t. So you have squaring both sides. X plus 2 is equal to t square, or dx is equal to 2t dt. Now this integral I, this will become integral of 2t dt whole divided by t square minus 2 minus 1 into t. This t and t will cancel. You will have this as integral of 2 upon t square minus 3 dt, or I'm going to take this 2 outside. This is 1 upon t square minus root of 3 square dt. This is equal to 2 upon this log t minus root 3, t plus root 3 plus c, or you have this as 1 by 3 log t's value was root x plus 2 minus 3 root x plus 2 plus 3 upon c. So this is the answer to the question, and you have option D as the correct answer. Hope you understood this. Let's move to the next question, number 72. Again, an integral. So here you have, let's write it down. Let's say this is equal to I e raised to power minus 2x 1 minus sine 2x upon this. Okay. Right. Now, this can be written as e power minus 2x 1 plus. I will take the minus sign outside, inside. And you know that cos of minus x is equal to cos x, and minus sine x can be written as sine of minus x, right? So I can write it like this. I'll put minus 2x is equal to t, or you have x is equal to minus 1 by 2 t, or you will have dx is equal to minus 1 by 2 into dt. Now the integral I, this will become integral of, like I'm going to take minus 1 by 2 outside, e power t 1 plus sine t 1 plus cos t dt. So this is minus 1 by 2 integral of e power t. This can be 2 sine t by 2 cos t by 2 divided by 2 cos square t by 2 into dt. This is equal to minus 1 by 2 integral of e power t secant square, secant square t by 2, like into 1 by 2 also, and plus tangent t by 2 dt, and this outside. Yes. All right. So now let's open up. You have this as minus 1 by 2 integral e by this. So let's take this one also outside. Secant square t by 2 plus minus 1 by 2 integral of et into tangent t by 2 dt. This is equal to, see, one thing, I'll skip this step. You know one thing, that minus half e power t e power t. So this is half secant square t by 2. Question number 72. If the integral of e power minus 2x plus this whole expression dx is equal to. So let's say this is I. You have e power minus 2x 1 minus sine 2x upon 1 plus cos 2x dx. Now this can be written as integral of e power minus 2x 1 plus sine minus 2x upon 1 plus cos minus 2x, because you know that minus of sine x can be written as sine of minus x. Also, cos x is equal to cos minus x. So I can write the whole expression like this. This was equal to I. I'll now put e raised to power, not e raised to power, sorry. I'll put minus 2x is equal to t, or you have a minus 2 dx is equal to dt, or you have dx is equal to minus 1 by 2 dt. Now this integral will become minus 1 by 2 will be taken outside, e power t 1 plus sine t upon 1 plus cos t into dt, or 1 by 2 integral. I'm going to open this 1 plus 2 sine t by 2 cos t by 2 whole divided by, this can be written as 2 cos square t by 2 dt. So this is minus 1 by 2 outside, e power t And this is equal to half secant square t by 2 plus tangent t by 2 dt. You know, this is the derivative of tangent t by 2. So this is equal to minus 1 by 2 at into this function. This will be equal to, this can be written as e power t into tangent t by 2 plus c. So this is e power minus 2x tangent of minus 2x upon 2 plus c, or minus 1 by 2 e power minus 2x into tangent of minus x plus c, or 1 by 2 e power minus 2x into tangent of x. This minus and minus, it's coming outside, so this will cancel. Here will be plus c. This makes option A to be the right answer. Hope you understood this. Next is 73rd question. Again, an integral problem. You have Sn is equal to this, and n is an integer. Then Sn plus 1 minus Sn is equal to. So you have Sn plus 1 minus n is equal to. This can be written as integral of sine 2n. Now n plus 1. So this will be 2n plus 2 minus 1 x whole divided by sine x minus sine n. This is simply sine 2n minus 1x upon sine x dx. So writing it properly, you have this as sine 2n plus 1x minus sine 2n minus 1x divided by sine x into dx. Or this is integral to cos 2nx, because adding and subtracting to both of them, okay, numerators, divided by sine x dx. You have 2 outside, cos 2nx dx. This is equal to 2 into sine 2nx divided by 2n. And you have plus c sine 2nx upon n plus c. There were the limits also. I forgot to put the limits. What were the limits? 0 to pi by 2. So here you have 0 to pi by 2, 0 to pi by 2. This, and this, right? So you have sine n pi upon minus sine 0 plus c, and you know this is equal to 0. So whole was divided by n. So 0 minus 0 upon n plus c, or c, ultimately it will be 0 only, or c. It can be 0 or it can be c, like whatever the answer may be. Let's check. I don't have any constant over here. So let's see. That means option C stands to be the correct answer. Hope you understood that. Next is 74 question. A is equal to 2n and b is equal to 2n plus 1 for all mn belonging to natural numbers. Then what is the value for this integral? Let's write down the integral. So I is minus pi 2 pi e power sine ax cot b 2n plus 1x dx. Here you have a as 2n and b as 2n plus 1. So your function, I'm just writing about the function. Now the function becomes e raised to power sine. A was 2n, so this can be 2n x cot 2n plus 1 2n plus 1 x. Rewriting this again properly. This is e power sine part 2n. The x was this sine x multiply cot 2n plus 1 into x whole power 2m plus 1, right? Okay, now if I take, this was equal to fx, if I take f of minus x, this can be written e power sine minus x. I'm going to write this power 2n. So this is power 2n cotangent minus 2n plus 1 into x power 2m plus 1, right? So this is e power minus sine x power 2n minus cotangent 2n plus 1 into x power this, or minus, this is minus e power sine x power 2n cotangent 2n plus 1 x power 2n plus 1, right? So that simply means that f of minus x is equal to minus fx. This makes your function to be odd function. And for the odd function, if you have like minus pi, 2 pi for any odd function, this is equal to 0. Because the limits like minus pi to the same on the positive side, the limit, the integral is always equal to 0. That makes option A to be the right answer. Hope you understood. Next 75 question. Consider the following statements A and B. So assertion says, A says integral 0 to integral A to B d by dx fx dx is equal to d by dx of this function. Okay. So see, when you have limits from A to B d by dx fx dx, this is given by fb minus fa. And if I take the right hand side, this is integral d by dx of integral a to b fx dx. This is simply 0. Therefore, question number 75, consider the following statements A and B. These are the two statements. You have to find out which of the following is true. So let's pick up the LHS, the left-hand side of the first statement. You have integral of A to B d by dx of fx dx. This is given by fb minus f of A. And if I pick up the right-hand side, you have d by dx of integral A to B fx dx. This is, see, this will evaluate to be a constant, and the derivative of any constant is equal to 0. So that means the assertion, oh sorry, the statement A is absolutely wrong. If I pick up the second one, B part, you have d by dx of integral of fx dx. This is given by fx. But here you have fx plus c, so this is also wrong. That means option D, that A and B both are wrong. That's correct. Option D is the right answer. Next is question number 76. You are given integral n to n plus 1 gx dx is given by n squared. And for all n belonging to integers, you have to find out the value for this given expression. You have minus 3 to 3 gx dx is equal to. Now I'll break it up according to this, n to n plus 1. So this can be minus 3 to minus 2 gx dx, minus 2 to minus 1 gx dx, so on till 2 to 3 gx dx. So this is equal to n square. Here this is n, the lower limit is describing your n. So this will become minus 3 square plus minus 2 square minus 1 square, 0 square, 1 square, 2 square, and 3 square. No, not the 3 square. It will be finished at 2 square. So this will be 9 plus 4 plus 1 plus 1 plus 4. That is a total of 19. So option A is the correct answer. Hope you understood this. Next is question number 77. This is an integral problem from limits are given from 0 to pi by 2. Summation n is equal to 0 to 4 sine n pi by 4 plus x divided by cos x plus sin x dx. Okay. I'll pick up the numerator first. I'll just pick up this one and solve it. So summation from n is equal to 0 to 4 sine n pi by 4 plus x. This is equal to sin x sine pi by 4 plus x sine 2 pi by 4, which is equal to pi by 2 plus x sine 3 pi by 2 plus x plus sine pi plus x. So this gives you sine x plus this will be 1 by root 2. I can write it like this, 1 by root 2 sine x plus cos x plus this will be cos x plus this will be again 1 by root 2 cos x minus sin x, and this is simply is equal to minus sin x. Right. Hope you understood like I have how I got this. Sine pi by 4 plus x is equal to sine pi by 4 cos x plus cos pi by 4 sin x. And this is equal to 1 by root 2 cos x, 1 by root 2 sin x. So I've taken 1 by root 2 common. This will be inside you'll have sin x plus 2x. Similarly, 3 pi by 2 plus x, this will give me this expression. Okay, now let's get back to our problem. This thing will be equal to 1 by 2 root 2. I'm adding these two ones, this and this. Sin x will cancel and you will have 2 cos x plus cos x, because this sin x and this sin x will also cancel. Okay, so this gives me root 2 cos x plus 1 by root 2. Wait, this was only there. Okay, I'm going to rewrite this line. So this is equal to root 2 cos x plus cos x, or I'll take cos x common, root 2 plus 1 into cos x. Now the given integral was, see, now let's fill in the numerator. Now given integral becomes integral of limits for 0 to pi by 2 root 2 plus 1 cos x divided by this thing. Okay. Taking this outside, you have limit 0 to pi by 2 cos x upon this. Now things are pretty simpler. I think now you can easily do this. So see, you have 0 to pi by 2 f of, if I'm taking sine x, this is f of sine x plus f of cos x dx. This is equal to this cos x upon f of cos x f of sin x dx. So now this expression will become root 2 plus 1. So here they are saying this will be equal to 1 by root 2 plus 1 into pi by 4. Sorry, this was equal to pi by 4. This comes out to be equal to pi by 4. So you have this answer, root 2 plus 1 into pi by 4. Now let's check with the options, which is the correct one. Option D is the right answer. Hope you understood this. Next is question number 78. So it says dash is the general solution for the differential equation. Then the order of the differential equation is. Question number 78, let A and B be the arbitrary constants and C be the fixed point. If y is equal to this expression is the general equation of the differential equation, then what is the order of that differential equation? So you have here y is equal to a e power 2x plus b x e power 2x plus c. You know, order of differential equation is equal to of differential equation is equal to number of arbitrary constants. Arbitrary constants in its general solution. General solution. So that is equal to 2 over here. So that means the answer to the question is 2. Option B is the right answer. Hope you understood that. Let's move to the next question. Question number 79, the differential equation y squared dx plus 3xy minus 1 dy is equal to 0 is, okay, let's write it down. 3xy minus 1 dy is equal to 0. So dividing both sides by y square into dy. Dividing both sides. You will have a dx upon dy plus 3xy upon y square minus 1 upon y square is equal to 0, or you have dx by dy plus 3 upon y into x minus, I can write it like this, is equal to 1 by y square. This is the linear differential equation in x. So option D is the correct answer. Hope you understood this. And now let's move to the last question of the paper, question number 80. The particular solution of the differential equation. This is, let's write down. Okay, fine. I'll start from here itself. You are given this differential equation. Now this can be written as this is equal to sine y plus y into cos y x 1 plus 2 log x. Now this is equal to, I'm taking x common from here. Sorry, this was dx upon dy. Let's do the cross multiplication. X into 1 plus 2 log x dx is equal to this. And now integrating on both the sides, you will have 1 plus 2 log x into x square upon 2 minus 2 upon x into x square upon 2 dx is equal to dy into sine y. So this is equal to 1 plus log x into x squared by 2. Here will be integral of x dx is equal to this, or 1 plus log 2 log x into x squared by 2 minus x squared by 2 is equal to this. I'm gonna take x squared common. So you have this thing. 1 and 1 will cancel. You have x square, and this 2 and 2 will also cancel. After cancelling this 1 and fine, then this 2 and 2 will also get cancelled. So you have log x squared. Log x is equal to y sine y plus c. Okay, so particular solution at y1 is equal to 0. You are given y1 is equal to 0. That means y is equal to 0 when x is equal to 1. So you have this will be when x is equal to 1. So 1 square into log 1 is equal to 0 into sine 0 plus c. So c will be equal to, because log 1 is equal to 0. So you will have c is equal to 0. Now this particular equation, it will become x square log x is equal to y sine y. That's it. So here you have option A as a right answer. Hope you understood this. Let's move to, okay, so sorry, we have finished with this paper now. So all the 80 questions of this paper have been finished, and I hope you have thoroughly understood all these questions. If not, you can rewind the video and watch them again. And for a much better preparation, don't forget to visit our website, www.examsnet.com. You must download our app. The link is available in the description box. So very best of luck for your exams. Keep shining, keep rising high. That's all for this paper. Bye.